All right, I think we can start here. And to be honest, I don't know why Sebastian asked me to present him, because I don't think he needs to be presented because he's pretty famous. So in any case, I will present him. I mean, now we have on stage Sebastian Ramirez. He's going to talk about deploy FastAPI on the cloud. Thank you, Sebastian.
Very much. Wait. Thank you very much. Like, I wanted to be presented by Ernesto because, like, he's a big friend of a company, big friend of, like, helping organize everything in PyCon Italy, and, like, we appreciate him so much. And we know that he's going back. Yes, Ernesto.
And now I'm embarrassed. Thank you.
We also know that he's going back to Naples. Napoli? How do you say that? Naples. I don't know. And we brought him a gift so that he can eat a proper pizza with the right ingredients on top.
Thanks.
Thank you very much.
Thank you. Yeah, I don't know what to say, but I'm...
Say it after you leave the microphone. Leave the microphone, and then you can say whatever you have to tell. No, the pineapple is for you.
Yes, but okay.
The response can be done afterwards.
Thank you, Seba. Appreciate it.
Nice. Thank you very much. This was the highlight of the talk. Like, after this, you can actually leave. Like, this was the best part. Okay, what is this asking me? I don't want to know now because you already see everything. Nice. We're going to talk a little bit about deploying FastAPI to the cloud. But first, I wanna calibrate what I'm saying. Is the sound okay? Is it too loud? Is it okay? Okay, cool. First, please let me see. I have a lot of content, so I'm going to have to cut a little at the beginning or at the end or at some point. So I want to check the audience a little bit. Please raise your hands if you work with computers. Okay, great. This is a great baseline. Otherwise, we won't have much to talk. Now you work with Python. Please raise your hands. Yeah, raise your hands if you work with Python. Yes, that's great. That's great. Nice. Raise your hands if you have heard of FastAPI. Nice, quite a bunch. And now raise your hands if you have worked a bit with FastAPI, like you have used it a little bit. Okay, quite a bunch of you. Nice. I see a few people have not used it yet, so we're going to talk a little bit about what is FastAPI, and then we'll continue just like to build some FastAPI app live coding, which is a very bad idea. Never do this at home. But yeah, anyway. So first, let me turn on the laser pointer, fake laser pointer. Okay, yes. I'm Sebastian Ramirez, or Tiangolo. I am from Colombia. That's why the accent. But I live in Germany. You can find me online on different things. I created some open source projects, and now I'm building with my amazing team, FastAPI Cloud, which we're going to talk a little bit about later. And how many Italians are here? I guess a bunch, right? How do you say B in Italian? Api. And if there are multiple? And if they are fast? Okay, nice. That deserved an applause. That's so cool. This is going to be great. Okay, if you got one of our T-shirts, you can see that in the back, it has the FastAPIs, because it's like a special Italian edition. Nice. We're going to talk a little bit about FastAPI, but probably not that much. So FastAPI is an open source web API Python framework. It has like a bunch of GitHub stars. That are probably not a great measure, but as Nicolas was telling us. But like it's still cool. Like currently FastAPI and then Django are the most starred GitHub frameworks in all programming languages. So that's great. Yay. It also has like a bunch of downloads. It has like 3 million downloads daily. So that's a lot of people probably using FastAPI. And if you do the calculations, it's like around 90 million downloads a month, which is a little bit more than the population in the UK. So that's nice. A lot of FastAPIs being downloaded. It also has been growing in the Python official developer survey over the years. And it has been growing also in the Stack Overflow developer survey that mixes fast API with AngularJS that had nothing to do with just I don't know, web, whatever. But yeah, anyway, it's cool. That is growing. So fast API stonks. Yay! Another way to see about fast API is which companies uses it. You might recognize a couple of the logos there. It's also used, maybe you remember these pictures. It's from the Space Telescope Institute. So from the Space Telescope, the James Webb Space Telescope. Fast API has nothing to do with that. Up to that point, they pick the pictures on the science data, send it to Earth, and then from Earth they distribute that using Fast API. You don't have to read this. I just said it. So they distribute the science data from the Space Telescope around the Earth using Fast API. They also use it in a bunch of places inside of OpenAI. When you are generating those very cool images, that's all a bunch of Fast API underneath. And it's also used to simulate galaxies. And doing that, they were able to discover to observe the first quasar. I have no idea what that means, but it sounds super cool, so it deserves a light. It's also used to control the particle accelerators at CERN and in Brazil and in the United States and at different places to control particle accelerators like the Large Hadron Collider. So if you see a black hole on the sky, maybe create an issue because it might be my fault or fault, you will see. Now, let's build an actual Fast API app. This is what we are going to do. So this is the final objective. So we are going to create a badge for the Fast API docs to check how many discussions have been answered over the total discussions. So if you go to the if you have a question around Fast API, you will go to the GitHub for Fast API, check the discussions, then ask a question there. So we have a lot of questions, and I would like to measure how many questions have been answered over the total of questions existing. GitHub doesn't have a way to show that, so that's what we are going to build at the end. We're going to start with, well, you actually already know a lot of Python, so we don't have to start with installing UV and setting up everything. We're going to start doing code right now. And again, I don't know if you know, the rule of live demos is that live demos never work. They always break. So only brave souls run their slides on live demos, like Nicolas. Bless you too. But we're going to try it out. Bless you again. In Colombia, we say salud, dinero, amor. Okay, so let me try to increase the font a little bit. This is what we're going to do. We're going to start. Can you hear me well? Okay, yes. We're going to start with a demo app first, just to explore a little bit. So we're going to make let me jump to my code directory. This was not this was a previous talk. So we're going to make the Ernesto. This is our project. So we're going to go into this directory, and then we're going to say UV init. And now we have a project Ernesto to work with. Now we're going to say UV add Fast API. We're going to install Fast API here with all the dependencies. So this should work. Nice. Now we're going to add, this is just some extra dependencies that we are only going to need now while we are in the early alpha. You won't need to run this later. So now we're going to have this application here. And we're going to start with a Fast API app. But most of you are already familiar with Fast API, so I'm not going to explain that much. Well, just a little bit. So from Fast API, we import Fast API. And this is still starting, so I still don't get out to completion. I might be typing things wrong. Let's see. App equals Fast API. We are creating an instance of the class Fast API. I forgot how to type. So much pressure. Anyway, so we have this, and then we say app.get. We're not going to use async. We're going to use regular def. Read root. This is fine. Return message hello world. This is good. Nice. So we save this. And actually, can you see that well? Should I increase the font? Let me increase that. Is that better? In the back? OK, good. Let me move this a little bit to the side. Now we have this. Let me activate this environment so that I have the Fast API command. So if I say which Fast API, this is going to tell me, yes, you are using the Fast API that is inside of the virtual environment that belongs to Ernesto, which is great. Now we're going to say Fast API dev. This is the development server. Underneath, this uses a UV core. But we have it in a very handy command line there. So this is our Fast API app. So this is the code that we write. For those of you that don't know Fast API, this is a Fast API application. This is the automatically generated documentation site. So we can try it out, we can execute it, then we get the response. So for example, we can go and say, let's say, app.get, we're gonna say toppings, and then we're gonna have a user ID. And we're gonna get what are the favorite toppings for each user ID. So we're gonna say read toppings user ID. This is not gonna be an integer, this is gonna be a username, and this is gonna be a string. And now we're gonna return, okay, let's just return this thing like this, just to try it out. So we save this, once we save it, it's reloaded automatically here in the development server. If we go back here, reload the page, now we have our additional endpoint, if I can click. Yes, we have our additional endpoint here. Toppings, user ID, we try it out. We say, foo, yes, this works, fine. Now, if we say, we're gonna be very careful with what we say, so we're gonna say data, this is equal. We're gonna change this data a bit, so we put it here, data is here. But if the user ID is equal to Ernesto, we're gonna say data toppings append pineapple. We save it, oh no. We're gonna see, did I do this right? Yes, this is just not being able to get it. Let's try it. So foo should be able to, oh, null. Ah, yeah, we have to return data. So this is now being, data is a dictionary. Oh, thank you. The data is a dictionary, so we have to, yeah, wait, data, and from data we are extracting the toppings, and this is not knowing that this is, it's because this is assuming that the dictionary is a dictionary of strings. So we're gonna tell it like, yeah, actually this is just a dictionary of anything. Just like to tell it, don't worry, which is something that you should not do at home, but yeah, anyway. And now if we say foo, then we get the same data back. If we say Ernesto is the user, we try it out, then we have the extra pineapple. Yay! Now we have an API for Ernesto. Yay! And now let's say that we want to deploy this to the cloud. So I'm gonna show you very quickly how FastAPI Cloud works. For those of you that don't know, we started working on FastAPI Cloud like for a year and something ago, and we just announced it like a couple of weeks ago. So this is how it looks like. I'm gonna say FastAPI login. Like, I mean, FastAPI is open source. You can deploy FastAPI anywhere you want, and you can like keep using FastAPI however you want. But now there's a very simple option to deploy, so you can try using our product. I'm gonna authorize, bless you, salud, dinero. I'm gonna authorize this. So this should be authorized, and then I get the response. Okay, this is authorized. Now I can say FastAPI deploy. And then this is gonna ask me, do you want to deploy this application? Yes, I want to deploy it. Which team? The team Sebastian or the team app 2, which was another team I had created. Yes, this is on Sebastian. Do you want to create a new app? Yes. The name is Ernesto. Yes, let's try Ernesto. Do you want to set up environments? I don't want to set up environment variables. I don't need them for this. So we're just gonna deploy this. And now we are seeing that we are deploying this application. So what we are doing here is that the CLI is taking our application and the code and the dependencies and sending them to our cloud, not the dependencies, the description of the dependencies. And then in the cloud, we go and build like the whole application, the whole thing, and we just like, like do a lot of stuff underneath so that everything just works. And then you get an application that is already deployed here. So if we go to https://ernesto.fastapicloud.dev, and we open this link here, now we have the message hello world. And then we go to docs, then we can see that this is here working. Let's try it out. Ernesto, execute. And now we have an API for Ernesto with the proper toppings for the pizza. And this is already deployed. This is already there. It's like, like HTTPS, everything is working. This is the point where I was expecting something will have broken already. So I'm very glad. I can stop sweating now. Nice. Now, actually, let's go and build the GitHub app that I was telling you. So GitHub has, let me show you a little bit first. So let's go to FastAPI. So when you go to FastAPI, let me increase the font a little bit. Is that good? I think that's probably good, right? If you go to FastAPI, go to the discussions, then you can start with a new discussion to create a new question. So like, what is the type of thing that you're trying to ask? I'm going to ask a new question. And then you get a bunch of information that we are asking you to give us so that we can help you faster and more easily. So we try to guide you. Okay, I have 10 minutes. We try to guide you on how to ask a proper question. So we are going to use the GitHub API. And I'm going to be a little bit faster this part, because I probably don't have that much time. So I'm logging into GitHub. GitHub has a GraphQL API and has a regular REST API, let's say. And some of the parts in GitHub are available in one and some are in the other. So we are using the GraphQL API to ask, hey, I want to, from the discussions in some particular repository, I want to know what are the total counts of discussions. And I want to filter them to check if they are answered or not. So we have some variables in here. We have a variable for the name of the repository, the owner of the repository, if it is answered or not. So this is sort of a function, and we pass the parameters of the function as JSON variables. If we execute this, then we're going to get a response saying like, hey, yes, this is the total count of these discussions that you have. So we're going to copy this. Then we're going to create a new file here called github.py. Then we're going to pass this here. No, not like that. GraphQL query is equals to, this is a very long string, so we're just going to pass this here. And then we're going to import, we're going to create a function that is going to be get discussions count. Yes, this works, but I need the type annotation, so otherwise I will freak out. This is a string. This is a string. And this is a Boolean. And this by default is going to be false. Yes. And now we're going to say the response of the request that we are doing is httpx.post. And then we are calling the GitHub API, which is this API. We are sending the JSON data. Inside of the JSON, you will pass a query field, and this has a string. This is a single string inside of JSON, and this string has all these GraphQL query. And we're passing the variables, what is the name of the repository, the owner, and if it's answered or not. We're not going to do the headers yet. Actually, yeah, we're not going to do headers yet. We're just going to do it like this. And we're going to say return response.json. And we say if, name, blah, blah, blah. This part is just to tell it to call this as a script whenever we are not importing it. And we're going to say the result is going to be, no, don't import result from something. Yes. And we're going to print the result. Don't autocomplete everything. GitHub Copilot has been just too friendly. Nice. We have this here. If we try to execute this with call GitHub, this is not going to work because it's going to ask us for a GitHub token. So we're going to go and create a GitHub token in GitHub. I'm going to go here. And you're going to see my token live all screen, and it's recorded and everything. So this is super insecure. Never try this at home. And never do it live in a talk or anything. No, but it's actually fine because like this is just a token that I'm going to get with only read permissions, and I'm going to delete it after this. So it's fine. The name of the token is clearly Ernesto because this is our API. It can only read public data. Just generate the token. We're going to copy this token here. So we're going to, let's start by just pasting it here to check that it works. What did it do? So we're going to say token equals this thing. Never paste tokens directly in your source code. Don't do that as well. Like they should be in environment variables. We're going to do that in a bit. There's a, okay, now we have to pass the token here. So this is going to go in the headers. What happened? Yes. JSON. Headers is going to be authorization bearer token. Yes. And I'm doing something wrong here. And I'm not sure. Yeah. This should be below the other parameters. This is just part of the JSON. Did I do it right? I hope so. Yes, please format this so I can see what I'm typing. Yes, this works good. So this is how we pass the token to GitHub. If we call this again and we print that, we should get the response. Yes, we have so many discussions answered, so this should be fine. We're going to say whenever there's an error, just raise for any status response that is not that everything is successful. So we have this here. Now what we're going to do is that we're going to create another file just temporary that we're going to call env, and we're going to put in there this token because we don't really want to have that in the code. And we're going to say GitHub, but we're going to say token is equals to OS imports this dot get env, and this is gonna be GitHub token, but don't autocomplete a token. I don't know what this is. The whole point is not to type it there. Yes, that works. I have 5 minutes. Dang it. Okay, now let's call this thing again. So if we call it without the token, this is not gonna work. If we pass the token, GitHub token with the value, this should be fine. So where is the token? Here's the token. We're gonna copy this here. We're gonna pass the token here. Now this should work. Okay, this works. Now we're gonna import this thing in our application. So we're gonna say app, app.get. And we're gonna say this is gonna go to the repo, I guess. Repo name, no, owner, and then repo name. And then we're gonna return some data from this. Now from here, we're gonna say data is gonna be equals to get, what was the name of this thing? This is get discussions count. Get discussions count, import that with the repo name. We're gonna say answer to. Let's check how many discussions have been answered. I think I'm already sweating. This feels like disarming a bomb. I have less than 5 minutes. We're gonna return that data. We're gonna say like, okay, what is the total of questions answered? Total answered, because this is returning us, you know, like this JSON, we need to extract the data from that JSON. So total answer is gonna be data, we can probably just like say data, this goes to data, the repository historical questions, total count. Yes, this is the right path. And now we're just gonna return, a dictionary that has total answer, this is total answer. Let's just start with this. So one of the things that we need to do is we need to set this token in our application. So I'm gonna go to FastAPI Cloud. Let's go to the apps. This is the other one that I was trying before. Now we need to go to this team. And there's a lot of here, Ernesto. And you know, like I have one that is called live demos always fail. It hasn't failed so far, but it's probably gonna fail at some point. Okay, we're gonna add an environment variable. So this is gonna be a GitHub token. We pass here the value of the token. We save this thing. And now we can deploy this thing again. Where are we? Here. So we can say fast API deploy. Amor. We got salud, dinero, and amor. I don't know what to say there. I think Italians say something, but I probably don't know. Now we are deploying this thing again with the new app that we just, with the new code that we added to get the tokens, to get the discussions answered from a public repo. And this is now again in the Ernesto API. So we're gonna open this. Yes, open that one. We just like change some things. We added the token, and now we can say, let's try it out. So this is now deployed, right? This is in ernesto.fastapicloud.dev. It's just the changes that we were doing, like we just deployed that again. And now we're gonna say, give me the discussions that have been answered for. FastAPI is the owner, and FastAPI is the repo. If we execute this, probably gonna fail. No, it didn't fail. So everything just worked. Nice. We got the total answer. I don't know how much time we have. We have 2 minutes. We can do this quickly. So we're gonna go to Shields. So this is this nice website to create badges. So we can create a new dynamic JSON badge. And we're gonna say, what is the API for this thing? This is gonna be this. Fast API, blah, blah, blah. This is the URL that we got. And we're gonna use a JSON path expression. So this is some weird syntax to get the values out of JSON. We're gonna say total answered. So I think it's this one. Let's try this one. Yes. And we're gonna say style. Where is the content of this thing? Label. Answered questions. And we execute this. And now we have a badge that we can put in the FastAPI docs. We can just like include this. So we made it. We made a full FastAPI from scratch. We asked GitHub for the data that we needed to put in the badge. We created the badge. We deployed it to the cloud. We can start using this right away in the time that we get for a talk. I think this is what we can cover for now. I had a lot of extra info here, and I had a bunch of memes in case things fail down, so I could be able to entertain you in some way. Some of the things that you should have in mind, I think is here. Yes, so you can deploy Fast API however you want. You should be aware of like a bunch of things that you should have in mind. There's a lot of docs in the Fast API website about how to do deployments, how to think about them. Some of the things that you should have in mind are to have security, to have HTTPS for everything, so that everything goes encrypted. You should have in mind how are you running things on startups, so that if the machine turns off, if you have like a remote Linux machine, it should be starting again. How to handle restarts whenever like you have like upgrades to the system or things like that. How to handle replication. So if you have a single machine, handling replication is going to be a little bit harder because you are handling a single machine. If you want to have like multiple machines because you have a ton of users, then you're probably going to have like, I don't know, Kubernetes or like some cloud provider or something that can do this for you. Then you have to make sure that you handle memory, and some previous steps that you might need to run, like doing database migrations or things like that. I had a lot of extra slides to show you how to deploy things on Linux manually, but we are not probably going to be able to do it. So, but you can check the docs. There's like all the information is there. If you can check them and like check how to deploy by hand, or you can just try Fast API Cloud. That also works. It's probably fine. This is what I have for you for now. Thank you very much.
Thank you. Thank you, Tiago. Thank you, Sebastian. Do you mind if I take the pineapple with me during the Q&A?
Yes, please.
Okay.
It's yours.
Thank you.
I will be offended if you didn't take it.
I really appreciate and really discussed about the toppings that you associate with my name. But anyway, let's move on to the Q&A session now. We have a bunch of questions, so if we are not gonna make it, we'll just ask Sebastian outside.
I'm gonna be around in the hall, and we have a booth over there.
And he has pineapples. So.
Yeah, we have pineapple. Well, actually, we had only single pineapple because it was very exclusive. But we have coffee.
Yeah. So first question is, it's great to see that you're solving a critical part of moving from local to prod, eliminating the overhead. Can you share how you hope to solve issues like scalability, optimizing cloud consumption, and stuff like that?
So like the scalability of applications that are deployed?
Yeah.
So the thing that we are building, when you deploy an application to Fast API Cloud, we handle scalability automatically. We replicate your application based on the requests, and we also handle scaling down to 0 automatically. So if you don't have any requests coming in, we also handle that, so that you can save costs and all that stuff. This is how we are doing it. You know, like there are many other approaches if you're deploying on your own, but like this is what we have.
Great, thank you. Second question is, when Fast API Cloud will be available to the public?
So right now we have the waiting list. If you join the waiting list, we might invite you to the beta. That's the idea. We're going to start, right now we are doing a bunch of UX research interviews and like making sure that we have like everything in place, tweaking paper costs. We're going to start onboarding people to the private beta in the next months. So yeah, like join the waiting list, so you are one of the first to try it out. And if you join the waiting list, there is a secret code. You can use PyCon IT, as in PyCon Italia, all in lowercase. So we know that you, where you come from, and that we know that we can offer you pineapples and that stuff.
Okay, thank you. Another question. Where the Fast Deploy command ship the API to, is it to a cloud-hosted service by Fast API? Can we leverage this to deploy into our own cloud provider, like Google platform or stuff like that?
So right now, Fast API Cloud is our own cloud, so you will deploy to our cloud, and we will handle the rest. You will pay us instead of paying AWS or Google or whatever. We are figuring out what are the next parts of the product that we need to build. So if you are a large enterprise that requires deploying on your own AWS account or something like that, like you can also tell us, and there's something that we might end up needing to build. But like, yeah, for now, we are just trying to focus on the simplest use cases of Fast API and making the developer experience as good as possible, and like, like keep it in line with Fast API itself to make it super simple to go from idea to production in as little time as possible. Okay,
now your choice. You want the smart one or the dumb one?
The dumb one, of course.
The dumb one. The dumb one is, what does it mean, ready the chicken?
Ready the chicken. That's actually super clever. That's super important. So ready the chicken is actually not that great of a story. In Colombia, when we say, and in some parts of Latin America, when we say something is ready, we say listo. But sometimes we just add listo el pollo, which is, it means the chicken is ready. I have no idea why, but we as Colombians like to make sometimes jokes of just like translating word by word and saying the expression in English, and then like no one else gets the joke except some other bilingual Colombians, and then like we say like ready a chicken, and now you have to live with that in the CLI whenever you're deploying. But now you know why.
Okay, thank you. I'm sorry we don't have enough time for further questions, but
it was
please.
also it was also to satisfy the needs from Nicolas to have chickens on the cloud. Yes.
Thank you, Sebastian. Thank you very much.
Thank you.
Here we have Sheena now, and that was an amazing keynote last year. Thank you for coming back. And yeah, she's going to talk about front-end for Python web apps. So thank you. The floor is yours.
Awesome, thank you. All right. Hello, everybody. Is this okay? This is on. Cool. So once upon a time, if you wanted to build a front end for your web application, it would look a lot like this. This was the modern state of the art, and it was a simple time and a simple place. So we used to build websites like this. We'd have a back end that maybe served some static files, and if we were really fancy, we would render some stuff on the back end, maybe using PHP, and the web browser was just a web browser. It just displayed your stuff, and it was simple, it was easy to get into. Things have changed a lot, and they've changed because of needs. They've changed because of the needs of our end users, our clients, the people who use our stuff. So one of the needs we had was for the front end to be able to fetch data from the back end without needing to reload the whole page, and we needed to re-render parts of the screen, so Ajax and jQuery became a thing, but our code became kind of spaghetti-like. That was not something that scaled to the levels of complexity that we needed. So things like Angular became a thing. Single-page applications became very, very popular. But we needed to scale things in different ways. We needed reusable components. React became very popular because of that. We needed more efficient ways to render different parts of the DOM without doing it immediately, like render it in RAM and then render it on the screen. So the virtual DOM became a thing. Meanwhile, JavaScript was trying to keep up, and it was tough because you can't upgrade JavaScript in a way that breaks the internet. And so we needed tools to transpile it back into old school JavaScript so that browsers could still run the stuff. Tools like Webpack became really popular because not only did we need to transpile things down to old school JavaScript, we needed to do it in a way that minified the code, because now our applications were full-on applications and they were big. Sass and less made CSS more manageable as well. We needed our stuff to look good, and CSS was not handling it. We needed variables. We needed a few other things, and even that was kind of tough for people to wrap their heads around, and so we had all these component libraries coming up. So Material UI is one. Shad CN is pretty popular at the moment. And on top of this, the web platform itself has been improving and getting better over time. So things like the Shadow DOM and web components are now a part of the web platform, which is really cool. But it's complicated. Like, all of this is complicated. And if you look at this, if you follow the story, there's a pattern that we can see. And it's not just a web development pattern. This is not just a front-end development problem. This is a human thing. When we have problems, we add more stuff, we add more solutions, and those solutions introduce new problems, and then we solve them, and then there's another problem. And that's how we ended up with this crazy stack of front-end tools. So what if we did the opposite? What if we thought about things from first principles and just honed in on what we needed instead of having to build on top of what we've got? How much of the stack is actually technical debt, and how much of it is something that we actually need? So, hello everybody, my name is Sheena. These are my emojis. I've been coding for a long time. I've been coding since I was a teenager. Mostly I've worked for a lot of different startups. And I spent the last 5+ years working in software development education, basically taking people with potential and turning them into people with careers. And that was quite successful. So I was doing that in a nonprofit in South Africa. I'm a nerd about education. I like taking the science of how brains work and turning that into engineered experiences to help people learn different things. So it's pretty fun. I'm quite involved in the Python community overall. So I organize conferences sometimes. So PyCon Africa is happening in my hometown, and I'm the chair this year, which I'm excited and terrified about. I'm also part of the PSF's Education and Outreach work group, which is a mouthful. I really like education. Have I mentioned that? So I founded a thing called the Guild of Educators, which is for people who enjoy teaching code or do it for a living or want to get into it. So if you want to join, you can join and nerd out about education with us. And I have a company called Prelude that does technical training, so mostly focused on advanced Django stuff and also soft skills. So that's who I am. Let's get back to the code. So the web 2.0 architecture looks kind of like this. This is vastly simplified, but you tend to have a front-end full-on application running in browsers, and they talk via APIs to a back-end application. And like, that's cool. Here's a more concrete example. So this is an application that I was running with a team. So I had a team of devs, and we had this thing. So on the back, we had Django. We needed some APIs, so Django REST framework. We needed to secure those, so Guardian was good for that. That's like nice object-level permission stuff. Then we had some JSON APIs consumed by a React front-end. We needed some state management, so Redux was there. We needed side effect management, so that's Saga. And we needed it to look reasonably good. And so we were using Material UI as a component library. So this is a lot. It's a lot of different things. And it's hard to actually be productive on a stack like that because you need a lot of different skills. So front-end development is complicated. So I just want to show you this link. Let me just F11. Oh, it's already open, but who's seen this before? Like, if you want to be a front-end engineer, it's no longer just something that you can do. It's proper engineering. You need to learn all of this stuff. And that's a lot. Full-stack developers exist. They're not a myth, but they need a lot of different skills. And the challenge with having all of these skills and working in the full stack is that you're actually kind of a lot slower than you would like to be, because you keep needing to change contexts. You keep needing to think about, okay, how does the back end consider this problem? How does the front end consider this problem? You're working with different code bases. You're switching between different ways of viewing the world. Deployment and versioning is complicated. The front end expects some APIs to have a certain shape. The back end needs to expose APIs of that shape. And now you need to keep these things in sync in a specific way. And maybe you can solve that with even more tools. So it's complicated. So it's complicated for the people on the ground doing the work. It's complicated for us developers. But it's also pretty bad for organizations that write code. So organizations that do web development typically don't hire a lot of full-stack developers because full-stack developers are either expensive or considered to be magic unicorns that don't exist. And so what typically happens is you have a front-end team and a back-end team, or at the very least a front-end developer and a back-end developer, and they work together. But you can't just take like half a front-end dev and half a back-end dev and call it a full-stack dev, because it's the same problem as like you can't take 9 ladies and then get them to make a baby in 1 month. It doesn't fly because there's complexities. You need to get people to communicate. There are handover issues. There's back and forth that needs to happen. So there's a tax on this complexity. And so you need more tools, perhaps. GraphQL can help. The front-end people can decide what APIs they want on the fly, but that introduces more problems. Maybe the thing that you need to do to handle all the extra handoffs and task juggling is like project management tools and project management capacity. Maybe you need to hire an extra person just to handle that. So it's complicated and it's suboptimal in many ways. Now, since I love education, I've worked with a lot of junior developers and gotten them to a point where they can get a job, and it's actually really hard because people don't hire junior developers for web development as much as they used to. Web development used to be the gateway to get into software development. Like when I was in university, I used to code for money, as one does, and like I was doing web dev, and it was fine. Now that's no longer an option for a lot of people. Like organizations typically don't hire juniors. Typically, they'll only hire intermediate devs and upwards. And that sucks because juniors are people too, and they struggle to get the experience they need to be useful. But it also sucks for the future because there's going to be a talent vacuum. And who's going to fill that vacuum? I'm not even talking about LLMs here and the effect that they're having on the job market. Like, the stuff's going to get weird, and there aren't going to be enough skilled people around to deal with it. So we like Python. we know that simple is better than complex. And I'd like to say that there's a simpler way to do web development. So the core of a web front end is HTML. It's all about like, HTML tells you what's on the screen. You just need to get it to behave in a certain way. You need it to update in a certain way. You need it to look a certain way. But it's all about HTML. That is the core. So can we make it good enough? What would it take to make it good enough? So what do we need? We need to be able to fetch information from the backend whenever we want to. And sometimes we need the backend to be able to push information to the front end. This is also a thing. we need to be able to render and re-render parts of the screen based on that information. And sometimes we need state management. So like maybe we have a menu, we click on it, it opens and closes. We need that kind of thing, and sometimes we need more complicated state management than that. But often we don't need as much as we'd think. So I want to talk to you about two simple tools that give us all of this in a really elegant way. So the one is HTMX. Who's heard of HTMX? All right. Who's used HTMX? All right, cool. It's cool, hey? And then the other one is Alpine.js. So HTMX, for those of you who haven't used it before, it is a JavaScript. Oh, I have a thing going on. It is a JavaScript library. It is tiny. It is simple. And what's cool about that is it works on old devices and slow networks. It's really small. It's basically how it works is it adds a few simple attributes to HTML that give you control over a bunch of different modern front-end interactive things that you might want to do. It allows you to fetch HTML partials from the back end and then render them on the screen where you need them to be. So you're conditionally re-rendering parts of the screen. So this is the hello world of HTMX. It's pretty simple. We have a button. And when you click on the button, we send a post to this endpoint. And then there's a response. That response has some HTML in it. And we're taking this whole button and we're swapping it out. That's what this line does. We're swapping out the whole button with the HTML that gets returned. So this is a pretty simple little hello world, but hello worlds tend to be that way. You can really tie HTMX actions onto any kind of front-end event, and you can use any kind of request. So here we're sending a post, you can use a get, you can use a put, whatever, and you can decide on where you want your partials to go. You can update multiple things at the same time if you need to, and you can update them in different ways. So sometimes you want to replace an element, sometimes you want to put a thing inside another thing, or put it at the top, or put it at the bottom. So there's quite a lot of control there. Now, I want to show you an example of how you would do something similar with React. So this does something comparable. It's not exactly the same, but it's comparable. This is the React way of doing things. Notice how long the code is and how much it looks like code instead of configuration. It's complicated. There's a lot that can go wrong here, and there are some like weird things happening as well. So here we've got a div, right? Let me make it bigger. Like the main thing I want you to see here is the complexity rather than the actual code. But if you're familiar with React, then you should be familiar with kind of what's happening here. So we've got a div. And if there is a message, we display the message. And if there isn't a message, we display this button, and then it's got a handler. Like when you click, you call this handler. Where's the message? The message is in the state, which is set up here. Then the click handler is this thing over here. And what that does is it fetches stuff from the endpoint that we need to hit, and if there is a response and it's okay, then we set this thing again, and then we re-render this because now the state is like it's complicated. And imagine like if you're writing a serious application, there's like a lot of stuff like this. It gets to be quite a lot of code just for a simple thing. So that's the difference between HTMX and React. Of course, React can do a lot that HTMX can't do, like state management, for example. So this is the hello world of Alpine.js. So Alpine.js is similar to HTMX in a lot of ways, in that it's a tiny little library. It's very, very simple. It gives HTML superpowers by giving it a few extra attributes that do different things, and you can do modern web stuff with it. So this hello world, basically what it does is it says we're going to define a variable called open, and open is defined within the context of this div. Open is false to begin with. You can set open to true by clicking on this button, and when open is true, you display this content. So you can use it for menus that open and close, and tabs that change, and you can do cool iteration things with it as well. But it's nice and simple to look at, and it's pretty, like if you just look at it, it tends to make a lot of sense off the bat. So it's simple. And the question is, like, what is the simplicity worth? So there are web front-end wars underway at all points in time. JavaScript fatigue is a thing. When I first heard about Alpine.js and HTMX, I was like, oh, it's another one of those. People are saying that they are revolutionizing things, but it's just going to be another one of those. But the simplicity is worth a lot. So here's that project I was talking about. So I was running a team that was doing this, and I had a bunch of people who were trying to be productive, and we were grinding and we were moving forward. It was working, but we had a bunch of team members who were just drowning, especially the junior team members. They were really struggling. And so if we wanted a junior team member to be productive, we needed to craft their tasks just so that they would touch certain parts of the stack and not other parts of the stack, and need to keep track of what everybody knew about so that we would set them up for success. That was a workload. And then even then, a lot of people needed like a lot of support to be productive. It got to a point where I was like, I think I'm going to have to fire some people. And that made me sad, and that made them sad, but it was very hard to get people to be productive. Then I heard about HTMX from somebody that I respect quite a lot. So I was at DjangoCon US, and there was a talk by a guy named Chris May. And he was talking about how HTMX made a React front end like way more efficient. And I was like, damn, I need that. The application we were building was for people in Africa. It was for students from under-resourced backgrounds who wanted to learn some stuff. And so they had slow devices, terrible networks, and we were running this React app. And it worked, but it was slow. And so I was like, we need something that's better for them. Let me try this HTMX thing. So I experimented. I took this, and I sat by myself, and I hacked at it for a while, and I was like, what are the weirdest, hardest things we're doing with our React app? Can I do it in HTMX? The answer was yes. The answer was, it's not hard. So I got my team to try it out. I got the most junior of junior people on my team to try it out, and they were successful. Whoops. And so the project ended up looking like this. We re-architected things completely. On the back end, we just had Django. And we did server-side rendering of static files. And those static files used Alpine.js and HTMX tags. And it worked. So this was a great simplification on the stack. And it was fantastic, because personally, my developer experience was improved. I could move way, way faster. The same team members were adding more value. Everyone was a full-stack developer, including our juniors. Like, that's unheard of. And on top of that, our code quality was way better. So I showed you that little example of like the React code versus the HTMX code. For an entire code base for a learning platform, like we had a lot of React code, and it shrunk down significantly. So it was tiny, it was easy to reason about. And so that meant that there were fewer bugs and a faster dev team. It also meant that testing and versioning became much easier. And our complicated pipeline for the front-end build went away. And deployment was simpler. It was just better. And of course, our clients had a better time as well. Our end users could use the application at a reasonable pace. Earlier on, I mentioned organizations that do web dev. They have a whole lot of different problems and different solutions to those problems. A lot of these problems go away. Who's heard of Conway's Law? Yeah, okay. So Conway's Law says that if you have an organization of a specific shape, then the systems that you produce tend to be in the same kind of shape. And if the shape of your organization is dictated by your tools, then like that can work. But what if, instead of being constrained by the tools that you're using, you just shape your organization according to the problems that you're trying to solve? That's kind of cool. But wait, there's more. So again, I love junior devs. I love finding ways to get people into this career. So tools like HTMX and Alpine.js, lower barrier to entry for web devs. It gives organizations larger, cheaper talent pools that they can choose from. And that's fantastic because it means that there's less risk in hiring staff to try out different things, and there's less risk in hiring junior staff because they can be productive soon. One of the reasons organizations don't hire junior staff members is because they'll hire them, they'll pour effort into training them, and then by the time they get useful, they leave, they go somewhere else and they get a bigger paycheck. But if they're productive sooner then that's great. That's great for everyone. And it gives people an opportunity to grow. So hopefully I've given you, those of you who haven't really heard about HTMX yet, hopefully I've given you an excuse to at least try it out. Or I know that there are some people here who are trying to convince their teams that HTMX is a worthwhile thing. I hope I've given you some words to use in your context. But just in case you want some more, I'll share the slides with you. There are some links. Here is some HTMX inspiration. There's a bunch of blog posts and videos and things that you can look at. I made a Django starter project that shows you how to use HTMX with WebSockets to do cool real-time stuff and like how to test it and things like that. So you can grab that if you want to, and like come and talk to me. I train people in this. I will answer whatever questions you have. Yeah, so that's that. And yeah, that's it. Scan this, you'll get these slides, and yeah, that's it from me. Thank you.
Thank you very much for the talk. We have some questions online, and if you want to submit more questions, go to Slido. So we can start from the first one. I've heard modern front-end developers are so used to SPA and APIs, and they can't wrap their head around HTMX approach and server-side rendering. What's your experience as an educator? Can we teach simplicity to existing front-end devs?
I think we can, yeah, because I've done it. So it is possible, but it does require people to have an open mind. I think one of the cruxes of getting people to get into these tools is getting them to see the worth, that it is in fact worthwhile, because front-end web development has been evolving and moving in a specific direction for a while, and now we're like, let's go that way. Let's take a hard right. And a lot of people see that and they're like, ugh, you know, like it's outside of their comfort zone. It takes like learning that front-end stack is a lot of sunk cost as well. And throwing that away and trying something new, it's a scary move. So I think the main thing to do really is to look at them as humans who are being asked to make a big change and get them to just try it. Yeah.
Thank you. So next question that was also upvoted. In your opinion, what are projects where HTMX will not be the best choice, if any?
So I'm not sure, because I haven't really seen a ceiling to it. So one of the links over here within this thing is a talk that is just like an epic HTMX demo that shows you, like, it's like the mother of all demos for HTMX. It shows you a little bit of what it's capable of doing, and you can build some like very, very complicated front ends from that. So the fact that you can use HTMX to update multiple pieces of the page at the same time is fantastic. I think where HTMX falls short is on state management, because the way you would do state management with HTMX is like if you wanted to open a menu, you'd like send a request to the back end, and then the response would be like the open menu, which is inefficient. So it does fall short with that stuff. So if you've got like really heavy front-end state management stuff going on, and a lot of interactions around that, then maybe something else would make more sense. But a lot of the time, what you want to do is update the front end based on the back end. Yeah.
Thank you. Kind of related, could it be complex to have everything in the HTML? For example, adding Tailwind.
Yeah. So I think that is one like pretty valid argument against these tools, is that now your HTML code has a lot going on, and it's cool because of locality of behavior. But if somebody's new to the code base, you have like all this like X data and HX what, and then you have your long Tailwind classes, and it can become something that's a bit weird to look at. You can get used to it, but it can get to a point where you do need to put extra effort into organizing your code. And every time you introduce a new tool, you introduce new problems, and there are solutions to these problems. So a really simple one from Django land is a thing called Django template partials. That's a really nice way just to like split up your code into nice reusable partial chunks in a way that you don't get like template spaghetti. And then the other thing is that with Tailwind, you can create your own utility classes. So you don't always need these like super long classes. So the approach that I take with Tailwind is I'll have my own utility classes like primary button, secondary button, and all of those. And then I'll apply those as I need to in my HTML. So it's like clear and easy to reason about and easy to read, and you can see what things are for. And then I'll use other like normal Tailwind classes to handle the layout a bit. So it'll be like, cool, I'll add some extra padding over here. I'll put this in a grid. These should be in columns. So you have like your components in your code, and then you have the layout in the HTML. Like that's the approach I like. It simplifies things quite a lot.
Thank you. So next one is how to convince companies they can solve their problems with HTMX. Most are looking for React front-end devs.
Yeah. I think the story that I told here is something that I tell a lot of people, and I think that it works. Just showing people that, like, cool, if you do this, then you don't need all of these complicated structures, and you are able to hire different kinds of people, and you can structure your team in different ways. I think those are arguments that get people to pay attention, but the main thing, I think, is get people to try. Just give it a serious try. Yeah, like spend a weekend, spend like 2 days playing with it and be like, okay, cool, this does what I need or not. Yeah.
Thank you. So here there are another couple about when you cannot use it in a project, but I think we already mentioned that. So there is one about Django Ninja. So have you used Django Ninja instead of DRF?
I haven't, but keep going.
And did it also help to reduce complexity or the contrary?
So I think that DRF does a lot of incredible things. It does have a learning curve. So there is complexity there because now you're thinking about serializers and all sorts of stuff. One of the really cool things about Django is its complexity, actually. The fact that it has so many batteries included is very, very helpful. And DRF kind of sits in the same in the same bucket for me. So when you look at very opinionated web frameworks, then it's useful to think about where those opinions came from and are they worth learning from. So I was introduced to Python via Django. Like my first ever Python experience was a Django experience. And I look back at that time very fondly because even though there was quite a learning curve, like I was learning about how like really giants of our field construct web frameworks and what they think is important in the web. And so those lessons have come with me. Django itself is a great teacher. DRF is also a great teacher. It plugs into the Django models really well, so that compatibility is super cool. I think if you want to like make a quick and nasty thing, then like honestly, I haven't used Django Ninja enough to have a strong opinion on it. But my feeling is that it's more about being lightweight and quick. It's not necessarily about building the kind of large-scale consistency that DRF aims for. Yeah. Oh, and I also want to mention something else. The question about when HTMX is not appropriate. There is another talk by a guy named Chris May. I might have it in there, I don't remember right now, but he talks from DjangoCon US last year, and watch his talks about HTMX. He's really, really good at making it clear and making the trade-offs clear. Yeah. He talks about like when should you use HTMX versus other frameworks.
Thank you. We still have a couple of minutes, so there are a lot of questions. So, opinion on Flask versus Django with HTMX?
So I think Flask and Django solve different problems. Like you can use them to solve the same problem. You can like build an admin interface with Flask and things like that. You can get an ORM to play nicely with Flask. But the main thing to think about is like, what is your end goal and where is your application going? So Django has a lot of batteries included. It's not a small framework. It has that learning curve. But are those batteries useful in your life? Or do you want to make decisions about the different batteries that you use? Like, do you need to decide which ORM to use? Do you need an ORM? Do you need a template layer? What are you going to use there? Do you need an admin interface? What are you going to use there? I think one of the things that I really love about Django is that it allows you to build a scalable team. Like if you're running a Django project and you need more people and you hire a Django developer, they're familiar with all the standard batteries, so they can just jump in and be productive really quickly. They can ramp up really fast. If you're running a Flask project and you've made a lot of different decisions about what you want to use and how you want to use them, suddenly, like if you hire someone else, someone new, they're going to need to spend more time ramping up to familiarize themselves with what you're doing. So there's that trade-off. And like you can do really big, awesome things with Flask. It's just, and maybe you need to make different decisions about what you include in your application, and that's completely fine. But it's worth being aware of that trade-off. It's really worth thinking about the people who are writing the code and the people who are going to join you as you write the code. The other thing is that, like, Django is inappropriate for some things. If you are if you are building small things, if you're doing microservices, like, probably don't use Django for that. It might not be the best bet. So yeah, it depends on your use case. And then for all of these things, HTMX, like you don't even need you can use a file server and you can run HTMX code on your file. You can serve HTMX files or HTMX, you know what I mean. Yeah.
Thank you very much. So we are at time. Thank you for your talk. It was very interesting. Thank you.
Awesome. Thank you.
Autonomous driving and Python with Formula racing cars. Thank you for coming. The stage is yours.
Hi everyone, thanks for coming. I'm Ilias, and I'm here for talking about autonomous driving and so how a car can drive autonomously. And more specifically, how Python is in the system and how can contribute to this task. We'll see two perspectives. One of the normal city cars and another one from the perspective of autonomous racing car. This because I maturated 2 years of experience in the FRT, the racing team of the University of Florence, part of the Formula SAE international competition. And this task is difficult, it's complex to reach this objective of making a car drive autonomously. And so, as always we do as software engineers, we have to divide this task in simpler tasks. And in this case, it's even more important because we have to divide the efficiency and the complexity critical points. And from the beginning, we have the perception module, where simply we have to take the data from the external world and process the data in information and from about what there is in the external world. Then we have to understand where we are, because it seems simple, but it is not to understand where the car is in that moment. In fact, there is this famous slogan from the last century about it wasn't related to cars, but I modified it a little bit. And it's the car knows where it is by knowing where it isn't. This because it's a nice formulation about how the algorithms of localization works. But this, of course, can apply to robots and any other kind of vehicle. And then, when we understood what there is and where we are, we have to calculate and plan the trajectory we want to do. And after that, we have to translate that abstract concept of target point, velocity, curvature. We have to translate it in real-world operations. For example, how much brake we have to press, how much acceleration we have to press in the car for reaching the target properties. And all of this is integrated in the system integration module that makes so that these components communicate between themselves. And from a technology's perspective, we have actually to divide two cases, because when we want to implement some tests at the beginning, we can just do everything in ROS, the robot operative system. But of course, we want to make some parts more efficient, and both from a computational perspective and also algorithmically, and more specifically on perception module and trajectory, because as we know, for example, there are many computer vision models that can solve this problem, but we'll talk later about that. And we are here in PyCon, and so we can see more a perspective of Python, but it doesn't mean that these interfaces, these modules can be implemented in any way we want with multipurpose language or other, there is also RTOS or other frameworks. But if you're interested even in the control part, I suggest you this GitHub repository. But as you can see from the technologies, we will not talk here about specifically about control and system integration, but in case you are interested. And so, in the perception module, actually, there is a strong standard, because YOLO, is the main deep learning model that is used in this context, simply because the car goes in the high velocity, especially racing cars. And so in this context, we need the best ratio between object detection, precision, and also the speed of calculation. And YOLO is the best one for this kind of ratio. But nowadays, the standard is not only using YOLO, but also using LiDAR, so a simple radar that allows the car to find objects not by using a computer vision model, but these technologies. And nowadays, we can say that any company uses LiDAR as a standard and also YOLO or variations of it. But of course, we can solve this task with other kind of models. For example, image segmentation. The simplest is UNet, but it's of course slower. Or strangely, but even agents, because I've been in many conferences and talks in Berlin related to autonomous driving, and I can say that more than one person told me that in their companies they are building solution to perception using agents AI, so using an LLM. That I think that 1 year or two, any one of us here could say that's maybe impossible, because LLM is the peak of slowness related to deep learning models. But somehow someone is trying to solve this problem, putting the images in real time to the LLM and having a description of what is happening. And now I just want to say this briefly, because once I was in a restaurant in Florence with a friend. He's a front-end developer, and I showed him some of these programs. I will show later even to you. And he asked me how these plots are useful to us. And this made me think that sometimes the way we interpret data, maybe even in obvious way, for example, showing it in a map, can be strange for other people not in the sector. And so everything that can be seen from the camera can also be interpreted in some way using matplotlib. And I'm saying this specifically because talking about trajectory, the first task we are solving is to calculate the local trajectory, because at the beginning we don't know anything of what there is farther away, and so we have to calculate a local trajectory. The simplest algorithm is pursuit, that just using these two parts of the algorithm, firstly identify the target, and then using different calculations, using distance on the target point or the wheelbase of the vehicle, and a specific function calculates this angle. And the alpha is pretty difficult to see it without an image. And now we'll see a test of this local trajectory. Because as I told before, we have also to test visually how can it work in different circuits. Now we'll see just a single example. And as you see, the right cones are yellow and the blue ones are in the left part. And this is a standard in the racing competitions. And this is useful information we can use for solve this problem. And the orange cones are the starting and also the end of the circuit. Information that we can use, for example, using computer vision to understand that the circuit is finally completed, and so we can stop the car. Or we can use, for example, SLAM from the for the localization module for understanding that we are where we started, and so the path is ended. And when we finished a circuit, there is the possibility that we have to do it more times because there are different formats of the competition and one of this one. And so in that moment, we have more data, and so we can calculate the global trajectory. Because just a simple example could be that when we have 100 meters of straight line with a local trajectory path planner, it's difficult to, we are not going to do max velocity because we don't know if after 20 meters we have to change direction. And so in the local trajectory path planner, we will never go to max velocity. In the global trajectory path planner, we are going to do so because we have all the data, and so we know that if we have 100 meters of straight line, we can go for a portion of it at maximum velocity, an advantage to not ignore. And there are, of course, different ways. The simplest is to just calculate central line, and as you can imagine, is suboptimal, is not the shortest, is not the fastest, but is the easiest. In fact, we'll see how to implement the central line solution. But then another simple way could be adding heuristics. And a simple one is, for example, late apex. Maybe if someone of you likes Formula 1 could see and understand well these kind of heuristics. And from this perspective, we are implementing pattern recognition algorithms because we have to understand that there are some kind of curves that we can exploit for having a better acceleration. And so these are very famous techniques. In fact, there is drivingfast.net if you want to see other kind of heuristics. This is another one famous for when we have two curves in the same moment and how to use both of them. And another simple heuristic, even simpler, is just minimizing the curvature that in some cases it could be useful. But we are in 2025, and so machine learning is, even in this case, the best one in finding the best solution. And there are two approaches. The first one is supervised learning, training it with a data set of historical, of competitions, of circuits in Formula 1, for example. Or reinforcement learning in the case we don't have any data set. And so reinforcement learning can actually be used also for the local path planner, but in this case it's even stronger. And with, of course, a reward minimizing the time. It's important, not the shortest path, because as we saw before, it's not the same thing. And we saw that central line is the easiest. In fact, we'll see now how to implement it. First of all, we have to understand which problem could we have for solving these central line waypoints. And here there is just a simple representation with red cones and left cones. And here, a simple problem is having not a smooth path, because we have 4 waypoints, but the second one in red is incorrect waypoint because it creates a not smooth path. And so at the beginning, we have to make sure that there are not too many waypoints, too many draft waypoints, but to create the optimal numbers, so then we can fit a line on them. And of course, also the association kind of solution is not working because it could be one of the first things we could think, but the cones are not in the same number. And so the solution is using some kind of triangulation, but which kind of triangulation? There are many with different conditions. And so, for example, in this case, we have 1, 2 AB cones, and 1 A2 is, it seems to be the correct triangle, but why? We have to understand why. So which are the conditions for creating a good algorithm? And the solution is just using Delaunay that maximizes the minimum angle. And this is useful because having a low angle, we make sure that the waypoints are in the correct number, but they are not too close. And so we can have a good ratio between having a good path and also the good number of waypoints. Now we'll see this algorithm in act with an example. And so we'll see in the same circuit of before, we can first of all calculate all the possible Delaunay triangles. And as I told before, we have to interpret this image because we know that this is our circuit. And so we have just to filter the triangles we don't need. And it's simply done by removing the triangles where the free cones are of the same color. And so filtering them, we have the internal triangles. And so each part of the triangle is used for calculating the central point. And so for having a more close perspective, each of these is a central point. And so now we have a draft of the waypoints, and we saw before we have a good number, but we have to fit a line of them because, of course, we need a precise target point that the car has to do. And again, the shortest path is not the fastest, and even it's not smooth. So in our context, we want a smooth path. And so the solution is given by SciPy library with just the method of B-spline that is made by a couple of SciPy methods. The first one is spline preparation. That's a SciPy method that allows us to create a parametric function that describes that line, and so the path. But we don't want a representation of the function. So in this way, it's like an equation, but represented as a parametric function. But we want to evaluate then this function in some coordinates that, for having the same number between each waypoints, we can just use the numpy linspace for having, for example, 100 waypoints between each two main draft waypoints. And so even in this case, let's see the final example of a global circuit. As we saw before, we have the waypoints of before, but now we fit a line on them. And here we are also calculating the curvature. In fact, we are distinguishing the green waypoints and the red one depending on the curvature. And depending on the curvature, we later will calculate also the speed the car has to have in that specific point. And in case you want to personalize even more this SciPy function, you can just add some parameters, for example, changing smoothness or the weights that each draft waypoints have. And I have an economics student friend that once told me that potential resources are considered infinite, but we are in the real world, and so they are more than finite. And in fact, in this context, but always in software engineering, we have to find the best solution between running time of the program, the time we need for developing it, and the resources. And these two are not constant relation, because as you know, the paradox that the more software engineers you hire, the efficiency doesn't increase linearly. And so what can be optimized? Well, it's not nice to say maybe here, but a solution could be using C++ for the perception and trajectory, for having a faster calculation of this deep learning model. But it's not what we would like to do. So what can really be optimized? One simple solution could be using NumPy, because we apply many methods on NumPy and the arrays, and so the just-in-time compilation is useful for having better performance. But in general, the easiest way at the end is using sensors and cameras that can see farther, and this is one way for having a better performance. And I hope this has been a useful and interesting introduction to autonomous driving, and thanks for everything.
Thank you very much for your talk. So you can post the question online. We don't have one at the moment. Do you have any question in the room? Yeah.
Yeah, thanks a lot. I don't know if it makes sense, or maybe it's too technical. I was wondering if you can reformulate the problem of finding the best path within the circuit as like I guess a partial differential equation problem or a calculus of variation problem.
Okay. Well, do you mean specifically of the local, of the global, or?
No, the global one, of course, the global one.
Okay. Well, there are, I think, solutions, yeah, but we have also to understand that when a car goes really fast, we have to implement the fastest solutions. And I think that solution is not used for the reason that it could be computationally too... but that kind of solution, we have to also to understand that could work well in the racing cars, but when we have also other kind of objects, it could be a problem. For example, because in the city cars, also we have the, for example, prediction model, where we have to find the position of the next elements, the external elements, for example, pedestrians. And so this is all other computation added.
Thank you. So we have a couple of questions online. Do you memorize the circuit between laps?
Yeah, in the moment a circuit is completed. As we saw here, this is the matplotlib representation, but yeah, all the cones are memorized. And in fact, we are going to do the global path planning because we memorize it with, particularly we used also SLAM, for example. It could be a solution for creating the map that now we represent with matplotlib. So yeah, that's the correct way and the best way when we have to do more laps.
Thank you. The next one is, have you tested your simulation in the real world scenario?
Yes, we also tested in the real world. And in fact, one thing we could say is that why implementing the center line path when is suboptimal? That's simply because the path in the real world, at least in the context of racing cars, is not big. And so implementing much, better solution, but with weight from the computational perspective, it can improve for 2 meters or even less. But at the end, it's good, but it's also a cost for the team implementing better solutions. And so for this reason, testing in the real world is fundamental also for understanding what we should implement and should build.
Thank you. Next is, oh, okay. They keep switching. Depends on people how they vote. Okay, it's possible to calculate the best curve using genetic generation considering the speed?
Okay. I think that genetic algorithms are can be a good solution, but the standard, at least as I know, for the global, at least, is more on the on other kind of deep learning models because are more generalized, and so for this reason, I'm sure there are this kind of solution, but personally, I didn't see them at this point, at this moment.
Thank you. Next one is, what's the average speed reached?
I mean, at least for these kind of competitions, cars can go fast as, not as fast as Formula One car competitions, but over 150 kilometers per hour. So not as low.
Nice. I don't have any more questions online. Anyone? Okay.
Nice talk. And about the circuit. How is it mapped? Is only computer vision, or is there some information provided by the programmer? External of the car and.
Okay, well, it depends on the format because in some format the map is known, and in fact there are even famous and specific circuits that you can also find on Wikipedia. So pages just for a circuit, and so yeah, in that cases you can optimize the path as much as possible for that specific circuit, and this is what we do usually. Yeah, but. In general, we have to find a solution that can work everywhere, and so computer vision at the end is what we use for seeing the position of the cones.
Any more questions?
Stuff like that, because that actually changes the maximum speed. I was asking about the banking of the curve, because that changes the, for each turn, the maximum speed also depends on the banking, because you need to avoid that the centrifugal force will drift you away.
Yeah, well, the fact is that in the racing, the competitions, these kind of competitions, there are many assumptions, and one of these is specifically this one, because you have to see this sector as, for example, Formula One, where cars, or even in MotoGP, there aren't, you have a flat soil. Okay, at least for our assumption, as you saw before, I understand what you're saying, and I heard this thing many times. So I know that's a possibility that can happen, but at least for this moment, we are not too much giving interest on this specific point.
Thank you. I think there was one here, the last one.
Thanks for the talk. About the global trajectory approach, is it able to adapt in case there is maybe a temporary obstacle on the track?
Sorry, the obstacles?
Like a temporary obstacle on the track?
Yeah. Well, I'll go just a moment in a slide. This is the architecture of that we saw before, and the fact is that this is the basic architecture. Of course, real companies, and specifically for city cars, there are even the double or the triple of these modules, and these are the ones that cannot be removed. What you're saying is part of the prediction module that is between localization and trajectory, because we have to predict where the object, the moving object, are going, and so understand their movement for then calculating the trajectory. Well, you said that for the global, in our context, in the racing competition, we have just still objects. So for this reason, we are not taking into account moving objects. So the global trajectory is correct in its way, because there aren't any moving objects. But for the local, yeah, there are kind of solutions that do this.
Thank you very much. Again, very interesting talk.
Thanks.
Okay, 25 minutes. I send you minus 10, minus 5 minutes, minus 2
How many?
minutes.
25, 45?
Sorry?
Or 40 minutes?
Okay. Yeah, you're right. Sorry.
No problem. Don't forget about it.
Okay. Good afternoon to everyone. I'm very proud to be here with our next speaker, Maxim Danilov, and he presents his talk, Distributing Complexity in Huge Python Project.
Yep. Hello, everybody. I'm very proud to present my talk there. This is a first step in series of my talk about distributed complexity. And before I start, I want to say who I am. I'm Maxim Danilov. I'm more than 27 years in commercial development. Last decade, I work with Python, Django, JavaScript, and also I am award-winning in like a mentor in engineering. Last year, I provide around 6,000 minutes in a year. It means around 20 minutes every day without a break for young Python developers for free. I'm like a volunteer. And yeah, for this QR code, on this QR code, you can find link to slides or to whole repository about my talks on this conference. And the next step before I start, I want to say thank you for my family. My son Mark, my daughter Maya, my wife Elena, and Doc Marcel, Kat Kisa, probably they all, you can meet Sunday in hall because they are present on this conference. And also I want to say thank you for my children. They create last 2 years all illustration for all my presentation. Thank you, Mark and Maya. And okay, what is complexity? What is it? In reality, I start to speak about really subjective things. Because for somebody, one code is complex, for me is completely not, and other case. And that's why all what I tell about complexity is subjective. It's not, we don't have any objective measurements or ideas what is complexity. And if we start to investigate or to research complexity types, in this case, we have structural complexity. Structural complexity, this is complexity which grows if we have more relationals between objects in our code. And we can remove or reduce structural complexity by changing the coding paradigm. Also, we have cognitive complexity. A pretty famous part of complexity exists as is for really subjective, because for me, something is easy, for somebody, something in code is really complex. Can be reduced a little bit if my team follow the strict coding paradigm or coding style guide, which should exist for every project, and it should be changed to business to implement business goals in project. And accidental complexity happens as is. If we don't have a time, if we should to put something in production pretty fast, sometimes we find some compromises, and accidental complexity start to grow. And technical complexity, it's important, it should be, because technical complexity is our essential complexity. We solve the complex business task, and complexity from this task this is a technical complexity which should be implemented. It means it should not be reduced. We can frozen growing of complexity, but this complexity cannot be removed at all. Or, yeah, you can delete all files and you can remove technical complexity. Yeah. Okay. The complexity every time grows with project. For example, we have complex business task. It's okay, it should be. We have complex tasks to make changes as fast as possible. And also, for every project, we have some missing knowledge about our project. On the start it's probably one size. On the big legacy projects, there was 20 teams involved in development. Probably missing knowledge is already or already big lack of documentation, for example. And in matured project, of course, the complexity start to grow and mixed with other types of complexity, and we see we can obtain in matured project points of high complexity. For example, in some project, I open some file and I completely don't understand what is it, but it's my code. It's really complex to understand what happens there. And this is not a problem. It should be. But problem is if the complexity grows further. Because in this moment, the complexity starts clash together, and we can see growth of structural complexity if complex business task increase, quantity of business tasks increase, and we should always put it in production. Structural complexity grows. Also, accidental complexity. It's exactly place there it happens. We have missing knowledge in our project, but we should push something to production. And we find some compromises. Don't matter what happens, we should simply update it, and accidental complexity have a high growth in this case. And of course, the cognitive complexity grows if we have complex business task and if we have lack of documentation. Welcome, cognitive complexity grows. But this is not a problem. Problem is here, vortex of doom. And vortex of doom is it's not my invention. I like use this description of problem. It seems like we have issue to improve one bug, only one bug. Our developers working with this issue, improve the bug, send to production, and get 2 new bugs. And after that, we go to in the how it goes in cries and it's repeated, and consumes like a black hole full power of team. I have seen it one time in my life, and our decision on we have decided around 100 bucks. We've frozen development and we do nothing more because every new changes increase the bug more than helpful. It was a really frustrated project, and probably I'm happy what I am finished to work there. Okay, small recap. Complexity invented by humans. It's pretty subjective. Complexity is not the same as a touch depth. It's important. And complexity is not a bug, but can lead to bugs. And there is no way to keep complexity at low level, only if you don't work with this project anymore. If you freeze the project, okay, complexity not grows. Important is, if you start to manage complexity, it leads to better design of your project. This is really important. It means working about complexity is not refactoring. This is improvement of architecture in your project. And simplicity of code should be somehow documented or set it like KPI. This all in theory. Let's see how it works. Okay, measuring complexity. Count of code lines index. It's measure the project size or globality of project. It shows us the cognitive complexity, how big it is. And I use my own measuring tool, dependency instructor. I show the output. Cons. This matrix is completely broken if you use black, the formatter by RAF or Britier, because these linters or these formatters increase complexity automatically. And I completely don't understand why team use the short time benefits, like it seems all the same, instead of the long-term benefits. In this case, as many likes you have, as more complex project you have. And sometimes I meet different statements in one line. Okay, we can also measure it, how many lines use it. And sometimes I accepted it. Verbose code or long code can be more readable than a complex code, especially if I put it in one-liner with lambdas, generators, lists, and so on. Okay, for example, if we start to compare, DaVinci is commercial project, is around 1,000 lines in a project, summary lines of code around 50,000, max lines in one file is 2,000 lines, average 52 lines in a file, and we have a famous open source project. It's less files, it's around 900 files, but summary lines of code is 100. Okay, right now it's probably already 200,000 lines of code, and max lines per file, 3,000 lines in one file. It's completely not readable. Even for me, but I'm already works with big files. And average, we have 220 lines in a file. If we compare it with graph, you can see the DaVinci has strict style guide, which deprecated to write big functions, big classes, and to have many lines in code. And we have open source project there, not implemented strict style guide for contributors. And you can see in open source projects, of course, we have many code lines in the file. Thank you. And the next index. This index compares for us which art of paradigm you use, open object-oriented programming or functional-based programming. This index also can show us got functions, big functions, or got classes with many methods and attributes. Subjective measurement, but it shows us cognitive complexity and, of course, structural complexity. I also use my own tool to measure. I show you the famous tools to measure it. Which problems we have this metrics? If your framework or code use full function compositions like FastAPI, this is strange style, but this increase complexity if you use, for example, functional based style coding, and complexity grows if you use function compositions. And PyTest unit tests should not be counted for these metrics because, yeah, about testing, it's not code of our project. It's testing. Okay, for example, DaVinci commercial project has 3,000 functions, around 2,000 classes. And other side, we have famous open source project which presented themselves like object-oriented open source, but they have like 10,000 functions and only 2,000 classes. Okay, let's speak about oriented to open object-oriented programming in this repository. Okay, dependency index. Probably this is important part of our measurements because this is strictly shows for us coupling cohesion relations. I hope I should not describe what is it, but this is strictly measurement of structural complexity. I use again my own tool. You can find it on the GitHub or you can try it, but also you can find the official services which help us to measure it. Cons. Problem is if you use dynamic imports in Python or somehow import something on fly, this is a problem. Because dynamic imports I already show you open source projects. There they have billion dynamic imports and I cannot measure which dependency index exists in this project. Okay, for example, my tool measure in business project, we have 1,000 dependency, only 24 libraries should be installed, and I use only 100 built-in dependency from Python, and framework, you can see, find around 900 dependency in between applications in project, and use more than 1,000 built-in dependency. It means it really shows it is a framework which wrap and organize for us platform to build our application. Okay, measuring complexity official tools is in Sonar Cloud. We can find cognitive complexity. In repository from this talk, you can find the documentation how they measure cognitive complexity. Really subjective metrics, but yeah, you can use it. Cyclomatic complexity. To measure it, I strictly offer you to use Radon. This is Python library, and it's a perfect tool to measure cyclomatic complexity. Touch depth metrics you can find on Code Climate resource. They also offer to use some subjective metrics about touch depth, and also composite code quality index by Codachi, but Codachi is built on Radon. In this case, this is extended version of Radon, results of Radon. Okay, for example, cognitive complexity is not the same like cyclomatic complexity. It's not too complex cyclomatically, but cognitive, it's high complex example. This is example from SonarCube. Okay, recap about measurement. All metrics subjective. And before to do anything, please use collect some metrics. After refinements, please collect some metrics and don't forget to compare it. For example, you can find the article about Dropbox. We changed 3 million lines from the typeless lines to type hints lines. But which efficiency you get? Why you spend too much time, many teams, many people to do it? There is the result. We don't have any answer, as is. Okay, and let's go to the strategy to how to reduce code complexity or distribute complexity. Refactoring. Refactoring. Every time I see, we should refactor it. Oh, we need the whole refactoring. And this is exactly the numbers, how developers think about refactoring. Full refactoring for business apps recommended after 4 till 7 years. McKinsey research, updates with refactoring every 3 till 6 months, and full refactoring after the 5 till 8 years. Stripe report, developers spend around half time of work for refactoring. But stop, people, if after 4 years it comes full refactoring, why you should spend time to refactor right now if in 4 years it will be refactored again? It means it worth your time, the refactoring. the stupid refactoring. But I meet every day too much stupid refactoring. Sorry. Brief normally, I don't like it, but okay. And cast software report, if refactoring affected more than 25% from your whole code, please stop to do refactoring, simply write the new project at all. It's not my research. All links I provide in my talk or in the repository if I have PDF. Okay, but refactoring is not always a solution. Refactoring is convert all bugs and wrong decision in other bugs and other wrong decision at all. And let's go to the famous persons. Martin Fowler says, areas of high developer activity needs a zero tolerance attitude to tech debt. It's important. Somebody knows about high developer activity in your project. Somebody measure it. Somebody. Okay, let's see. Michael Fieser's offer to find places in our project there we have high developer activity. Info from virtual control system give a better sense of refactoring or developer activity. Okay, defining refactoring hot zones is pretty easy. At first, only few files change often, say Fieser's. Some files must be clean from tech debt and ignore the rest, it says Fowler. Links to these articles I'll also provide in these slides on the last slide. Okay, we have also Pareto rule. 20% of changes affect on the 80% of results. And first refactoring steps should be done there. I write my own tool to find, I get the full repository log, and I find the file which changes regularly. Any other files simply not change it at all. It was created, it was tested, and finished work with that. Please find the files which change it regularly, and please keep your hands away from other part of your own project. That's all. And you can use it, zero tech debt zone, really easy to find, and you can compare the business project. We have less files which change it regularly, and famous open source project, they have bunch of files. It's more than 300 or 400 files which change it regularly. It's okay. It's framework with big community. It's changed. And you can see also results. In business project, we have around 4 commits in one file. And we have in framework, it's around 100 commits per one file. Simply to compare it. Okay, refactoring recap. Refactoring is not a solution, but it can be a solution. Usually full refactoring happens in 5 years, and usually refactoring takes 40% of working time. And smart refactoring help us delay full refactoring for a time. If we change less files, complexity grows not too fast. Next. Next strategy to reduce complexity is increasing abstraction level. We can find the incredible article from Sandy Metz, Breaking the Behemoth. Somebody knows about it? It's amazing article, exactly about monolith, how we can refactor it. And Sandy shows us what, at start, we have simple functions. After that, we start implement new features, and simple function transforms in complex function. And to reduce complexity, we start transform complex function in a object-oriented abstraction with right implementation, I hope. And it's a little bit more complicated than simple function, but it's really much, it's really less costly than complex function. And I can accept it. I see it many times. I transform from function which have around 1,000 lines in a class, split it by small methods, and it works amazing and readable. Okay, for example, you can see from previous result, we have around 40 classes in business project and 65% functions. And on the open source project, we have around 20% classes and around 80% functions. It means complexity in this framework is still not reduced. Okay, let's go. What we have else? Increasing modularity. This is probably the important part of this talk, because we start to speak about modular monolith. And Casey Hightower, this is a person, the first evangelist from Kubernetes, described this idea strictly many years ago. Organize your business logic as modular as possible, break it up across multiple repositories, keep those components as component. How it's possible? I show you. And you can get serious reduction in complexity, and you can simplify management process. I create my own tool which implement exactly these 4 steps. For example, we have some project in startup which grows, and we have one entry point, second entry point, and we have also next entry point, and we can see some classes or libraries reuse it. Code can be reused from one entry point to other entry point. And the next step, we can see, we can take simply one entry point and collect all dependencies exactly for this entry point and put it separately. And other entry point also separately. If we can do it on fly, it means every time we work only with one entry point with small bunch of libraries and packages. Dependency instructor, which I create, do exactly this rule. You can see, I say, please, from project root, extract only one file. This file contains only one entry point. Example, DaVinci commercial project, I try to extract only one entry point from whole project. And famous open source project, I try to extract one entry point, like example. And you can see, in business project, I can find, for one entry point, I find 1,000 dependency. It's huge coupling. It should be refactored. And also, for one entry point in framework, we can see better situation with coupling, because only 900 dependencies find it. Okay, important. I use I-step-based parsing and collecting import nodes. In runtime, I don't have any coupling with the rest of the code base. It means I improve stability of one entry point, and working entry point with all internal dependency, easily containerizable as standalone service, and it's possible to pack in more entry points in one container and run it. This is example. In source, we have 2,700 files, 750 folders, and 21 apps. As a result, we have 750 files, 250 folders, and 11 apps. High cohesion. One application in my project coupled with other 11 applications. It's should be refactored. It's high complicated project which, yeah, written not good. And also we have background for changes. If I have the listing of imported classes, I can see one class from my project imported many times, and probably this is a candidate to extract this class like installed dependency. Okay, increasing modularity recap. In this case, we do 0% of refactoring. We can run it, run extracting exactly on the before creating the image for container. Okay, extracted model can be run at standalone and to isolate bug fixing. Extracted model can be run in monolith because it's still part of monolith. We have also reduced container image. We have reduced download time, faster testing, deploys, and cheaper if we use hosting on the cloud. And extract one procedure or one entry point can run it exactly before creation of Docker image. More about it, you can read in perfect article blog cycle from Camille Gritzbeck, Modular Monolith. I like this this part of Camille. It's pretty interesting. Okay, imports control. Oh, I like it. Yeah, imports control. Please, we have one famous rule, KISS. Keep import short. You can see from Django DB models fields import char field. What happens here? There. Why developers are at fields if I can write the same line from Django DB models import char field? Developers from Django specially organize all, they use all in header model to offer for developer to use official interfaces. Now developers don't like it. They always find their own way. And also from Django, we have recommended art how we work with objects from Django. No, it's also skipped. Okay, the keys keep import short. Please don't forget about it. Deep nested logic. This is really example. API, domain errors, observation, domain models, observation. This is example how Java developers after 20 years of work came to Python. This is, yeah, structural complexity, high. Mental load, incredible, because I don't understand completely what means this chain. Okay, we have TDD, famous acronym. Free dots deprecation. This rule should be in style guides. I know what means TDD in reality. Okay, and we can use linters like raf to control dot depth. Okay, we can also obtain complexity hotspots. If I find in one file 73 imports, can you imagine what happens in this file if we need more than 73 objects to work? I cannot imagine because I can keep in my head only 7 plus minus 2 objects. And this is a high complexity hotspots which should be refactored or minimum reviewed. What happens there? Okay, modularity recap. Control imports, it's control coupling in your project. Imports with many dots require more awareness about project. Incredible more. Avoiding short imports leads to fragile structure of your project. We can operate only with small count of objects concept, and many imports increase cognitive load. And refactoring imports usually don't need to be tested. It means you can refactor it without any testing. Okay, type hints. Oh, yeah. Okay, type hints. Blessing of course. If I see something like this, I think I see the winner of competition, the less readable code in the whole world. You can see we import some things only to get the types. It means we increase coupling only to use type hints. And in one time I think, what if I replace all type hints in project in typing any and remove unused imports? Simple as is. Okay, I do it, perform extraction, my own written tool. It's not exist nowhere because we have not too many crazy developers against type hints. And you can see, previously I already showed find 560 dependencies, external dependencies. After the reducing type hints, we have only 500 dependencies. But important is, previously we have 40,000 lines of code. After, we have 30,000 lines of code. You can simply imagine how complexity in your project reduced. It's like more than 20%. It's important. You can simply try it. But of course, somebody says, Max, but we have any alternatives? I like type hints, I don't know why. And at first, official way to use stub files. 0% refactoring. It means you can add typing in your zero typing project easily without any refactoring. Simply to add stub files. If you don't know what is it, please PEP 484 and read it. It's easy. Stub files don't create noise in code file. Any IDE or linter support it, and it can be creating stub files can be automated. It's important. I don't know why we improve something, invent something new if stub files exist schon many years. Okay. Also, we can use type hints in doc strings. For example, to generate auto documentation, we can put type hints in Sphinx styled docstring, and its IDE have supported it. It's collapsible. It means I can remove it from. I can collapse it in code and remove it from my eyes, and check can be automated. But if type hints required, if somebody, in some cases, somebody use libraries which really use type hints for code generation in runtime, I created the typing decorator. They takes from stub files or from doc strings the description of types and add it on fly in class. For example, this is example. This is not data class. And we have one function. We don't have any typing, but we decorate it with typing decorator. And after that, we get the data class, and we have annotation for any function or classes. That's all. I don't have type hints, but I have type hints. OK, type hints recap. Type hints increase cognitive and structural complexity. Type hints increase weight of package and code lines count. Stub file keep information about types, 0% refactoring in typeless project. Docstrings can keep information about types, and the typing decorator cover all cases, if type hints, of course, required. I have 5 slides. Sorry. OK, documentation. How with documentation we can reduce complexity? At first, documentation should be written in style. If I die, all should works. I have not seen many documentation which written in this style. We should write unknown information in documentation, not the famous information in documentation. It means if I die, who knows the password from Codebase? Or who knows there I can get a password from Codebase? And if we speak about security data, it should be written there I can get the required info. OK, and you can also ask LLMs to add known information. They do it perfectly. if it's important. But if this information is known, every developer, if he has a lack of documentation, can create this documentation on fly. That's why I'm not against LLMs for documentation, but unknown information should be written. Okay, let's speak about LLMs. Humans can operate the small count of concept. Nested logic can break understanding. Code readability is important for people's feedbacks. And documentation should be near to code and attention from developer affect on the quality of work. LLMs. Quantity of tokens, quantity of quality of tokens, and how cost is it. That's all. LLMs don't see any complex code. This is a problem. That's why AI can summarize statistically, perform reviews, add testing, collect and write known documentation, but they cannot understand complexity like humans do. Okay, please remember, complexity exists only in human minds, not in code. Final recap. Summary. Work with complexity leads to better design is important. Measure complexity. You cannot fix anything if you don't know complexity metrics. Please don't refactor before you get the complexity metrics. Smart refactoring is in a huge library is possible and wanted. We can isolate selected files and pack them into a separate package. Type hints increase complexity and coupling, and frequently important internal dependency. Extract, isolate, simplify, organize like external library. And you can try it yourself. Take a project, find zero-touch depth zone, like I showed previously. Get one file from this zone. Perform extraction for this file. You can use my library. Perform measurement. Apply some ideas from this presentation. Perform measurement again, and enjoy. Probably it will be improved. Probably not. I don't know. Grazie mille, Bologna. Grazie mille, you, for attention. My name is Maxim Danilov. These slides by QR code contains useful links, contains software developer research, and I show the last slide only if you ask about it.
Okay, thank you. Thank you for your interesting presentation. We have a couple of questions, but we have last time, so I try to answer two questions. Okay, the first is, what's the famous project, open source project?
Sorry, simply go to my repository, the answer is there.
Then, second one was relative imports, goods or bads?
Don't matter. If you have an import, already complexity grows.
Okay.
That's all.
Because you are so quick to answer, I pose you the next question was, do you consider the refactoring process as a good way of managing project complexity if we analyze the issues we want to fix carefully?
Usually, I don't have any issue about complexity. I have issue about bugs. To decide to work with complexity, should the project owner, if he says the metrics goes down, for example, performance metrics from team. Performance, how to measure performance from developer team, I also report from Stripe, I put in repository.
Okay, thank you again. That's all. Thank you.
Thank you.
So, welcome for the last edition of this year's PyCon Italy Lightning Talk session. Oh, I still see people are coming. That's amazing. Welcome, welcome. It's okay. I know we were trying to win the AirPods.
Fashionably late.
Yeah, the odds weren't in your favor, weren't they? Right? I guess so, right? So this is the last session. No more lightning talks until next year. Are you ready? Oh, I like the style. Sorry, couldn't find my waistcoat today. But I got this shirt. I think it looks nice.
I think he deserved it, right?
Yeah? Oh, thank you very much. No way. So, are we ready?
We can really see it's the last day, huh? Like.
Hold on. Oh, wait. What's that about? Did you put that on place?
No, that wasn't me.
I thought you had it there. Do we have the props in there?
Was it you?
No, it wasn't me.
Do you
It's
know
not me.
what?
No.
Do you know what?
Is this yours? Sorry,
it yours?
this is important.
I saw you raising your hand. Is it yours? Is it a gift for
is
us?
this yours? This is anybody's?
Rodrigo.
Okay, no, okay, certo, Rodrigo, but do you know the man? Okay, he's not serious. This is a serious safety problem. I gotta be fair about it. It could be anything.
Could it be dangerous?
Okay, we can open it there.
Are you sure we're gonna open other people's luggage?
Yeah, it's whatever. It's the last days. We can do anything.
All right. At least there's no lock.
Okay, so now if it explodes, it's only on this side. Yeah.
Safety first.
Okay. Ooh, I like this one. It smells great, by the way.
Okay. A waistcoat.
Wow, nice.
A panciotto.
A waistcoat. I like the style. I think it suits me. Yeah.
But who's this then?
I don't know. Can you grab something from the bag? There's still more stuff in there. Oh wow.
Oh man, there's another one.
This can't be a coincidence.
Who could it be?
I think I already saw this one.
Yeah?
Yeah.
I think you didn't.
Okay, let me see. Hold on.
Is there anything else?
Yeah, I think just hang on a sec. I'll be right there in a minute. Mate? Okay. Oh, this is really bad taste. Who would ever wear shorts with a waistcoat? Oh man,
who would
the man
ever?
has no style. Come on, guys, this is
Who would ever
unbelievable.
do that?
Come on, that's like a crime against fashion.
But then look, there's yellow t-shirts.
No, come on, it has to be from someone from the staff.
Do you think it's from the same person that I think it's from?
Oh no, man, it can be.
It can't be, right?
There's another one. There's another one.
Well, 3 days, 3 t-shirts. We like to shower, you know.
It's a sweaty one then.
Yeah.
I took the same one there. And what's that about? So can you take that one for a second? Oh man, no, this can't be real.
This cannot
What's
be
this
real.
Oh no.
Is someone trying to...
No, this can be... This can be me.
No.
No, it can't be him.
This is really bad taste.
No, he's from Naples too.
He would never.
No, he cannot never.
Oh my God.
Wait, hold on. I got an email.
What's going on?
Hold on.
No way. Sorry, what? Can you open it? Busted!
So that's him. Must be him. Apparently we got spotted him off.
I think...
And he's also, Valerio at Python.io. I mean, this is really like official.
I think all of the time passing the UK, you really corrupted
Oh no, I think you could. I mean, I need to change those lights. Like we can't do this anymore.
It got kind of boring, isn't it?
Oh yeah, no, whatever. So, yeah, too bad. Didn't go playing as well, guys. So I wanted to do like, who's your first lightning talk ever? Okay, the guy there. But I know he's from Italy, so we can skip this session. So this was all supposed to be that there are some things in Italy that you should do. And one of those is not put pineapple on your pizza, but you know, even people from Naples apparently do that. So that's quite bad. I'm sorry, I'm too...
We're tired, I guess.
No, it's not tired, I'm shocked. But we framed him nevertheless, so never trusted people from Naples. What did you say the first day, sorry?
No, I cannot.
Okay, no,
repeat this.
definitely. It wasn't that one. Sorry. So it must have been about something else.
It's on YouTube, by the way.
It's on YouTube. So, okay. So now, not to put pineapple on your pizza, maybe it has some special exemption from, I don't know, maybe some like pizza authority or something.
Pizza authority?
Yeah.
Lelio, would you agree that there's such thing as a pizza authority?
Rodrigo, yeah, we're talking with you. Okay.
This is massive
That's
confusion.
Okay, I think we can move on to the straight thing.
Yeah,
okay.
let's get
Don't put
started.
pineapple on your pizza. Keep that in mind. Also, lightning talks, you all know the rules by now, do you? Yeah, okay, so 5 minutes of your talks, all topics, all feelings, all experiences are very welcome. We invite you to share anything you want on stage, provided that you're grabbed for your ticket is chosen from the pizza box. There we go. I got another email. Let me see, okay. I got
Another email?
Ooh!
Come on. What's going on?
Oh no, whatever. Also a typo, I think he's gonna slam me for this.
Come on, let's get it started.
Okay, whatever, I mean, we can still, it's with us. Valerio, can you see us? Answer with an email if you're here. If you can see it.
Go on.
Man to God. Okay, so it must not have been him. But nevertheless, I think there's a lot of evidence to say that this was his. Whatever. Anyway, menu, right? So, not put pizza on your pineapples, not put pineapples on your pizzas, but do play the wheel if you feel like it. Once your ticket is picked up, you can be asked to spin the pizza wheel. Ooh. The pizza wheel! Oh, come on. The favorite part of the conference. So what's on the menu tonight? A very old classic, like the old-fashioned pizza margherita. Whoever is picked on the stage and spins the wheel and gets the margherita slice will have to behave like an Italian through the whole duration of the lightning talk. We invite you to go beyond the usual stuff. You don't just have to do this, you can do this, you can be a bit more like this. You need to also be mimic and do the faces right, okay? You have to be Italian in a way, okay? Do not pretend you have like a baguette on your armpit. That's not easily, okay? Okay, it's okay. So, hand gestures, be like explicit, okay? Behave. Your body's also a language, your first language, by the way. Secondly, pizza with mortadella, another classic from here. So it's great food, tortellini, pizza, but of course you wouldn't put tortellini on the pizza. Okay, needless to say. You can put bologna on the pizza. It's really great, especially pistachio, etc. You can also take away the tomato sauce, right? But if you take away the tomato sauce, you need to be careful with this. So we're going to give you a nice ride. And you will bring us upon a wonderful ride upon your Ducati motorbike. And there we go. With it. Throughout the lightning talk. So the lightning talk will be like you'll be driving us through lands of expression in just 5 minutes. So we're like a hell of a bumpy ride. Everybody has to eat the veggies, right? So whenever we're going to do this all together when this happens, if somebody spins the veggie slice of pizza, we're going to quick crack together. So this is the fun part, like the involved part of the lightning talk. We will choose, and by we I mean Alessia and I, will choose a word from the lightning talk's title, and when this word is pronounced, is uttered by the speaker, everybody will quack. So, for example, if I'm going to say the word is pizza, I'm going to say, ooh, you shouldn't be really putting pineapple on your pizza.
Quack.
I didn't say that, sorry, again. I really like pizza with cheese. Okay, there we go. Okay, you're still lacking energy, but nevertheless, we can make it work. Finally, we are venturing in the land of, we are trying to teach you what not to put on your pizza. So, we like pancetta on our pizza, okay, that's just clarify something. It works really well in some regions, but what should not definitely go there is BBQ.
Ooh.
Okay. So when this happens, you will be visually impaired when you deliver your talk. Finally, the biggest of sins. If you ever happen to pull the pick, not only will you have to hold the fruit of shame throughout the duration of your talk, but you also have 3 minutes to deliver the whole thing. Tough luck, too bad. You should learn your lessons. So, there are no announcements for today, so I guess we can start spinning, or actually drawing. The rules, of course.
Another email.
Another email, okay. Just as a reminder, you don't have to spin the wheel if you don't feel like it. It's totally fine. This is a safe space. You can share whatever you want. If you want to engage a bit more, of course, you're more than welcome. Let's just see yet another email. Ooh.
And in the meantime...
Thank you, Valerio. We love you so much. Un applauso for Valerio. Dai, come on. Hope you're having a nice time in Bristol.
Okay, I don't have a name on this, but the title is Overkilling Sequences Classification. Yes.
There we go. Welcome on stage. What's the name again? I didn't say. Okay, whatever.
And I think we can also draw the next one, so the next one can prepare.
Hey, come again with the name, please? Sorry. Fabio. Okay.
Big applause for Fabio.
So while we get you hooked up, who's going to be the second one?
Maxime with coroutine baked attributes.
Whoa! Yes, of course you can. You don't even have to ask. There we go. Come and see your fortune. Yeah, Bologna. There we go. So we're gonna pick up our fancy new gear, helmet. Yes, it's sponsored from Ducati. Latest model, very fashion, very safe. Gets all the tests done. Yes, yes. Do you have a license though?
I think just for the car, not for the motorbike.
Yeah, but I think like if you can walk on a 125, so it's okay. Okay. I mean, we've got a bit slower, but this should work. Keep in mind, one last rule, once the time goes off, you will start hearing from 10 seconds a really slow grunt. Oh, the time is, oh, it's already gone, whatever, it's already us, it burned us. Okay, there we go. Fabio, welcome.
Okay. Hi, everybody. This is my first PyCon, so I'm really excited, a bit nervous, so I hope what I'm going to talk about makes sense. We will end up this maybe with more questions than when we started. So today we are looking to sequence classifications, but we are turning them into images, and then we are using images to classify the sequences. So yeah, it's a bit weird, I know. Why? We can basically classify proteins, for example. They are a long sequence made of characters. Basically, we have an alphabet of 4, so A, T, C, G. We see one kinesis protein and one G protein, and so we will try to classify it. Okay, this is the sequences I'm talking about. It's really long, as you can see, it doesn't fit the screen. We have codons, which are the smallest informations that we have in the sequences. They are made up 3 base pair, which is, for example, the first one is ATG. Why those are important? Because we want to make like a frequency plot using their frequencies in the sequences. Okay, so for example, this is what we'll end up with. And in the middle, something happens. Okay.
Vroom.
I just forgot to ride my bike.
We're still in the garage now.
Okay, too excited. And so what we do, we compute the codon frequencies, as we said. So how many times, for example, ATG appears in the sequence, or TZC, and we create a phase plot. So like the one you see on the right. These basically tell us, for example, how many codons like ATG appear in the sequence, and we will use this plot, feed into the model, and try to classify the sequences using this information instead of the sequence, of course. And why this should work? Ride my bike. Well, you see those sequences are pretty similar in terms of frequencies of a codon, but they are actually different. So how they're placed in the sequence. So using just text, maybe we will make some mistakes, but using images, maybe this information is still passed to the model. And so what we used a vision transformer from Google. We've used Hugging Face to fine-tune the model on our data and just try to make some example. It was really fast, really efficient. And so why this type of approach brings us some advantages? Maybe we can try to get the full information of the sequences just looking at the global pattern of the sequence, just by looking at a single image instead of going through all the sequence. And also, all the images have a fixed size, so this should be better, I think. And then it's easier to explain. So if you try to interpret your results with SHAP, for example, for explainability, I think that the result looks better than just saying, look, this codon appears this number of times. And so, yeah, it's a fun way to try to classify sequences without using text at all. Thanks.
We went after the finish line. Thank you, Fabio. It was
a
really fascinating topic. So, Maxim, are you ready? Welcome. Oh, thank you. Aspetta. Okay, let's just do it properly this time. Oh, yeah. Oh, maybe, is it still Valerio? I just see.
What?
You can spill the wheel if you want in the meantime. Okay, no.
In the meantime, prepares Hugo with what's new in Python 3.14.
Woo!
You here?
Okay, yeah, it's there. Do you want to spin the wheel? No, that's not the worst one. But you will get some fancy new glasses. Wow. I like the style.
Nice.
Oh, I don't know, yeah. Are you going to do like a grill after we do this one? Maybe can you be the chef or something? Do you have something in mind? Okay. No, apparently, whatever. Okay, thank you very much.
What I should to do this with gloves?
Oh no, just wearing in style, I think.
Okay.
That's cheating.
That's a reverse prank on us.
There
you go.
Hello?
Hello.
Yeah. Hello, everybody. It's me again. And right now I want to tell you about coroutine-based attribute or methods in any classes. And this is a part of a series of my talks, what do you yield from? And who I am? I'm Maxim Danilov, I'm a wine drinker, I'm a professional skier, and I'm a trail runner. Some years ago, I made 3,000 kilometers in a year. It's around 12 or 14 kilometers in a day without any break. Okay. Special thanks for my family for the support. My wife Elena, daughter Mark, Keith, and Marcel. They are near the swimming pool right now. And thank you for my children for this illustration, for any my presentation last 2 years. Okay, coroutine-based attribute. What is it? What does it means coroutine? We define some function. We create the infinity loop into this function after the call of this function, and we use instead return, we use yield. It's okay normally, and what is important on this line, we return some value if it's asked to return, and on this line we set the new value which should be returned. In this case, in this function, I use the getter and setter in the one function instead of getter and setter depends. Independent. Okay, how I can start this coroutine? I run this function and I send I run the for loop, and after that I can ask value from this coroutine, or I can set new value in coroutine. Okay, let's take right now one class. We can create the same coroutine in this class, and also we can define one property with some name. And important is on init, I should run this coroutine to work, and after that I can get some value from attribute, or I can set some value from attribute. And why is important? Because this is unified gate for read and write. They can add validation, permission checks, logins, every ask from attribute value will be logged. Also, it's cached like protected, because if we made some computation, it will be cached till this coroutine works. Also, it's observable. It means every ask from coroutine or every change of ask of value or every change can raise event. It was open, it was read it was set it, and also we can make this value trade safety. And this is all. Instead of any getters, setters, or descriptors, you can use coroutine-baked attribute or coroutine-baked method. It's easy, and how you can try it, get code from my talk repository, run shell, create object, and check you how it works. And important is this method is like protected, because it's not easy to change this attribute instead of official way to send new value or to read the old value. Okay, thank you for your attention. My name is Maxim Danilov, and play the code by this QR code.
Thank you.
Exactly 5 minutes.
Yeah, for 20.
Nice.
Why? Yeah, while we wait for Hugo to set up, can we pick the next participant? Oh, thank you very much. I almost forgot. Oh, yes, the dongle. Do we have a dongle? Oh, yeah, USB-C to macOS dongle. Sorry, yes, sorry, the HDMI to USB-C. There we go. Thank you very much.
Big applause.
Grazie,
What's your name?
What's your name and why you are coming up on stage next?
No, next is teaching Python to kids of Namibia.
Whoa. Okay, welcome. He's already there, basically. So, Hugo, do you feel like spinning the wheel?
I'm going to skip it because I got some Italian things to surprise you in here.
Okay.
Ah, okay.
And then why don't we give you a snake instead?
Do you want a snake instead?
Yeah, sure.
Okay. This kind of makes sense, but for those who do not know, it's going to make sense in a minute. Or maybe more. Okay.
Let's go.
Let's go.
Hello, my name is Hugo van Kemenade and I live in Helsinki. That's a photo of me cycling on the sea. I'm a Python core developer and release manager for Python 3.14. My day job is also working on Python. I'm a fellow at the Sovereign Tech Agency, and we have funding from the German government to work on open source. Just as governments maintain infrastructure like bridges, they should also maintain infrastructure like open source. I'm going to tell you about some of the fun things coming to 3.14. The beta is out now. That means it's time for everyone to start testing and look for bugs. If you find a bug now, that means we can get it fixed before the big release in October. And you might find some places in your code to update, which helps you. One of the exciting new things in 3.14 is template strings. T-strings are a generalization of F-strings. Their syntax is just like F-strings, but with a T prefix. The big difference is T-strings give you a new template type. For example, here's a familiar F-string. It gives us a string, and here's a T-string. So far it looks the same, except we use a T prefix instead of an F. However, it has a new type, and the really interesting thing is we can access the internals of what went into the T-string in the first place. It's made up of the static plain text parts and the dynamic parts called interpolations. So the T-string gives us access to all the parts that went into it. An obvious use is to prevent SQL injection. The user gives you an untrusted T-string, and you can sanitize it before using it in a safer way. Here's another example. Let's say the user gives us some evil input.
Ooh.
With an F string, we just get a string. Well, that's not good. But with a T string, we get the input parts as well. We can then iterate over this new template, and then if we get a static part, we keep it. Otherwise, for dynamic parts, we can check if it's evil and fix it. And keep the rest. And this gives us sanitized input. You may have noticed the REPL in these screenshots has color syntax highlighting. If this was a live demo and not a lightning thing, you'd also see autocomplete. These are new things in 3.14. We started adding color in 3.13 for tracebacks and for doc test. And in 3.14, we've added color to unit test and the JSON CLI and argparse help. We've tried hard to pick colors which work well in dark and light mode, that have good contrast and are also still readable for people with color blindness. However, there's a million different terminals out there with a million different configs, so we've added experimental theming support. So you can tailor the colors as you wish. For 3.14, it's in the underscore colorize module. We'd like you to play with it, and we'll see about creating a public API for 3.15. Let's say we want to make the REPL more Italian. We can set a new theme in our Python startup file, something like this, and change this into this. Much better. Finally, we're organizing the first PyCon Finland in 9 years this October. Welcome along. Thank you.
Thank you.
Thank you very much, Hugo. The snake did suits on you. Download the beta of
Do you need this?
Python Py. Can we call it Python Py?
Yeah.
There you go. There's Snipe.
And the next one is applicazioni dell'AI in campo medico. Lisa Di Marco. You here? Nope. So we get a new one then. Flying solidly.
By Egon. Okay, get ready. Well, in the meantime, could you repeat the name again, please?
Sorry.
Swani. Okay, would you like to spin the wheel? Yes. Okay, it's really... What was it again? Is it the pineapple?
No, not
It's the mortadella.
Oh, it's the mortadella. You feel like taking a ride. I don't see a lot of enthusiasm here lying around. Okay. No.
Vroom.
Okay, that's the right spirit. Ready?
Okay. So this talk is more about a shout out to PyCon Namibia than me talking about anything or my trip. So I would like to introduce you to PyCon Namibia. And for those who don't know where Namibia is on the map of Africa or something, it's near South Africa. It's West African nation, Vroom. And it's one of the world's most emptiest country, and it is also the home to one of the oldest PyCon of Africa. Yes, so the conference was a 4-day conference, and I got a chance to go there this year in February. There were 150 attendees and nearly 20 speakers. And the first day was in one of the biggest university of Namibia, in the capital, Windhoek. And the second day was in the outskirts of Windhoek in a small school in a village. And the third and the fourth day was main conference. The first day was nice. We invited many students from the university to give talk, and few of us went there and volunteered as a speaker to teach them something about Python or something related to tech. The second day, we were in the school, and this was the best day there because we went to a part of Namibia which was village, and you will be shocked to know that whole Windhoek does not have good internet connection, but Python is there. So people are learning Python on microbits. People are learning Python. They know how to use Python, but there is no proper internet. Vroom.
Nice.
So so this is one of the nicest picture that I got from the conference. Sheena was teaching a little girl Python and coding on how to do it through microbits, and it was really nice to teach them there. After that, we have the main conference day where we have workshops, main conference, and speakers. But why I'm here? I am here because to tell it looks like a normal conference, but the thing is, they are not normal. They are taking Python to a place where the Python is reaching to a place where internet is not. the people don't even have a computer there. So they are buying microbits on the money that companies sponsor them or donate them. Python is going to a place where people don't have computer or anything. So it's not similar. Speakers are the air travel in Africa is very expensive. So people are taking 6 or 7 buses throughout nations to come to PyCon Namibia to speak about Python and to be part of the community. And whatever PyCon Namibia gets in form of sponsorships or any donation, they spend on these speakers to travel to come to their conference and see. They make all the thing public on their website, how much they are spending and anything.
Vroom.
So, vroom. So if you want to go to African market as a sponsor to PyCon, sponsor your company, or you want to donate something, or you want to help PyCon Namibia to be better in getting sponsors or getting anything, Daniel is one of the organizers. He lives in Netherlands and he organizes everything from Netherlands. He goes to Namibia every year to organize PyCon Namibia. And the other organizer is Mohahe. He's local from there and he's very active in the Python community. So please, if you want to volunteer or help them, please scan this QR code and reach out to them. Thank you.
Thank you. Vroom.
Vroom. Thank you very much. Egon, are you ready? Is this your first lightning talk ever? Yeah, so give me a welcome round of applause. Thank you.
And the next one is Andrea with the Queens of Rome, an overview of local pasta.
Oh, wow.
Andrea,
are you here? Okay,
Call him.
thank you.
Quick.
Do you want to spin with Egon, or?
Yeah.
Yeah,
Let's
okay,
go.
okay. These proud first-timers. Daring. All right. You can do it. No, Se vai a Roma.
Oh, the
Broccoli!
veggie.
Wow. Okay. Yeah, easy.
Easy.
I don't know what would happen to you if you spin. I don't know.
Okay, so what's the title about? Flying solidly, Python design principle.
Solid.
Solid.
Oh,
Must
yeah.
be
Okay.
solid.
He's giving a suggestion.
So just a warm up. Solid. Solid.
Solid.
Let's go.
I like the energy.
Okay.
Let's go.
Okay.
So the real purpose of this talk, apart from the fact that Luca kinda forced me, I'm Egon. I am a computer vision engineer in Immobiliare, and I'm the organizer of PyData Roma Capitale. This is us yesterday, and this is us at the last meeting. We held monthly meetings, so if you ever are in Rome, come visit us, come for doing a talk or anything that you want, and especially we have pizzeette and datatine, so you can also eat. So how many of you know what are solid principles?
Quack.
How many of you? Okay, almost everyone, because you are a good programmer. But I was especially a data scientist, and I work with data scientists, and we don't know what are solid principles. So let's see them. Solid principles are software-oriented lifelines for state maintainable designs. It's something that Uncle Bob, a big guy, said, and it really helps you to keep your code maintainable and reusable, testable, etc., etc. And we will see how solid principles can help birds be happier. So this is the first principle, the first solid principle. So single responsibility. A class should have only one reason to change, one responsibility. You can see that if we have just one class, the Sparrow is really having a hard time doing flying and saving things to DB. But if we organize the code better and we have a class bird that only makes him fly, he is more happy and other things can keep the code more maintainable. Second solid principles, open-close principles. Software entities should be open for extension but closed for modification. So for example, if every bird has a different flight speed, we should not obviously have a function flight speed in which we have an if-else for each bird. Instead, we should do something better. For example, have an abstract class bird in which we have an abstract method flight speed, and each bird can implement his own way. Third solid principle,
Quack.
Lisikov substitution. Subtypes must be completely substitutable for their base type without altering correctness. So for example, if we anticipate that we'll have some birds that cannot fly, like a penguin, we should not have the method fly in the class bird, because otherwise the penguin could try to honor a contract, but he cannot, so he could die. So maybe we should do something better. For example, having a different class bird and a class flyable, or maybe a protocol flyable, but now we don't have time to go into that. So then we have, for example, a mixable flying bird, and the penguin is just a bird that is happy to swim, like the seagull that can fly. So 4 solid principles. Interface segregation. Clients shouldn't be forced to depend on methods that they don't use. Keep interfaces small and specific. For example, you can see that we have a kiwi, a stupid Australian bird that cannot do nothing, cannot fly, cannot swim, cannot sing. It just can say peep, but he should not have the burden to raise not implemented error when we ask him to fly. But we should, again, like we were saying before, maybe we could have some protocols or abstract class for flyable, swimmable, so we can just sing because it's a stupid bird. Instead, the duck can fly, swim, sing, etc. Last but not least, dependency inversion. High-level modules should depend on abstraction, not complete implementation. So, for example, we shouldn't have an abstract class, a concrete class worm dispenser and a bird feeder class that depend on it. Instead, we should do something better, like have an abstract class food provider, concrete worm dispenser and seed dispenser, so things are more tidy, and the class bird feeder can take just a generic provider, and all the birds can have their own food. This was flying with solid principles. Right. So come visit us, and thanks.
Thank you. Andrea, you had to run from the other side of the conference to get here. So.
Lots of bird racism.
Thank you for calling him. Okay, let's go.
There we go.
Okay.
Thank you, Egon, once again. Absolutely. Take a seat, Andrea. Hello. Do we have time for another one?
Yeah, I think so.
Oh, yeah.
Maybe you pick the last one.
Ooh, the last one.
There you go. Oh, this fell off.
Oh, no, okay, you don't want that. I picked the one.
Does it work?
Ooh, I feel this one near and dear to my heart. Andrea with What Can the Terminal Do? Are you in the room? Yeah, please, get ready. Intermezzo.
Intermezzo.
Stacchetto. Le veline.
But is the projector off?
I think he got offended by the bird jokes. Ah, okay.
Yes. Woo! Spin the wheel?
Andrea, do you feel like spinning?
Let's go.
Yeah. Yeah, I like this interface.
A margarita.
Ah, but you're from home here.
Nobody picked the pineapple.
Yet.
Are you sure you don't want the pineapple? No. Okay.
No, he isn't.
That's right.
Does it? Can I?
Okay.
Because if I have to move my
yes,
hand.
absolutely. Yeah.
Of course. So first of all, I do apologize if anyone from you here is from Rome, but I prepared this as an Italian for my colleagues once when we did an offsite in Rome. So bear with me, and yeah. So I just made a small presentation because people keep asking me about Italian pasta. So I selected these 3 or 4 type of pasta that are from Rome that I named the Queens of Rome. Let's see. So when you're traveling and you are visiting Italy and you go to Rome, you can find, for example, the cacio e pepe. Cacio e pepe is a pasta with black pepper and pickled
and pecorino romano cheese, a lot of pecorino romano cheese. Okay.
You seemed a foreigner for a while.
A lot of pecorino romano cheese.
Okay.
Or you can have gricia. What is gricia, you may say? Gricia is same like pasta with black pepper, pecorino romano cheese, and guanciale. I think you start seeing a pattern here, but let's see. Amatriciana, okay, what's my amatriciana? Amatriciana is pasta with black pepper, pecorino romano cheese, something I've heard before, guanciale and tomato sauce. Okay, what's next? Well, the so-loved carbonara, pasta with black pepper, pecorino romano cheese, guanciale, and egg yolk.
Only the yolk.
I'm confused. No, you need to explain better. No worries. So what are the differences? There you go. So cacio e pepe is basically the base of this type of pasta. Then you can add the guanciale and you get the gricia. And then you have to make a choice. Yes, either egg or tomato. So you cannot do both. But pancetta, guanciale, is it the same? No, it's not. So here is a nice thing. So we have a pork, and the guanciale is basically the part of the mouth, and the pancetta is the belly, basically. Remember, no cream. Do not use cream. How to make it creamy? Because you see all those pictures are like creamy. So you melt the pecorino cheese with the cooking water. That's like that. Egg yolk in case of carbonara. Again, do not use cream or... yes, we get a bit hungry about this type of things, and we may be a bit offended, but don't worry, we don't bite. Not always. So how to cook pasta? I thought this was worth like at least one slide, because some people say, oh, I put all together. No, please don't do it. You boil the water, you add the salt when it's boiling, not before, otherwise you're altering the temperature of boiling. You add the pasta, and please do not break spaghetti, because otherwise, no, where is the slide? Otherwise, this is gonna happen again. And you stir a little bit, and then you wait basically the number that is on the package minus 2 or 3 minutes, so you can finish the cook in the pan. And after that, you drain it. So you drain it before putting in the pan, of course. That's it. Grazie and buon appetito.
Thanks.
Yeah, thank you for the cultural session. I think it really looks like a solid interface, like the pasta preparation. Yes. Yeah. Individual responsibilities for the guanciale. Okay, I see the patterns. I see why it's typical from Rome, by the way, too. It wasn't Dijkstra from home. What was her name? Uncle Bob?
From Rome.
Wasn't he from Rome? Like Uncle Bob. No. Okay, whatever. Welcome on stage, Andrea.
And I'm afraid this is the last session of the day. Ooh. But
of the year? No, this breaks my heart, man. Do you feel like spinning the wheel?
Yes, I absolutely will spin.
Oh, yes. Yeah, that's great. That's the right spirit. Thank you. Last chance to get the pineapple.
It's the bacon.
Okay, let's do this in style. You can also, no, Manish, can hold the bacon.
Hold the bacon?
Because otherwise, how can we tell them it's the end?
No, I want it.
Okay.
Is this, okay, yeah, the screen's displaying.
Amazing.
Amazing.
Only thing is, let's see. It's not, oh, there we go.
Are you using Arch, by the way?
No, NixOS, but close enough.
Whoa.
Right, there we go. Cool. We have the ability to see now. Right, so what can the terminal do? If you're here at PyCon, you've probably used the terminal in some shape or form at some point. And, well, first things first, I just want to clear up a very common misconception. This here is not a terminal. Everyone calls it a terminal. This is not a terminal. Technically, and I'm being very, very pedantic here, this is a terminal emulator. This actually just imitates an actual terminal. This thing here is a terminal. It's at the end of your computer interface. That's not a terminal, it's a terminal emulator. But with that being said, I am going to call the terminal emulator a terminal because that's what everyone does, and who cares about being correct anyways? Moving on, okay, so what can the terminal actually do? It can display text. This is what you paid for your ticket for. This is why you came here, to learn that the terminal can display text. Truly revolutionary. You can type into it, and you see what you've typed in. Wonderful, but that's quite boring. What's more interesting is that the terminal can talk back to you, of course. You can execute commands, and it will return the output to you. And usually use a shell, which is a program that sits in between you and the computer and talks to the operating system and talks to you, like Bash. And Bash kind of sucks. It's really, really bad. Everyone hates scripting in Bash because there's POSIX compliance, different programs, different scripts might run differently on different machines. It's an absolute pain to use. So of course, people have done what programmers do and they've made alternatives. Lots of better shells, and yes, better shells. Everyone's going to argue about it. All the Linux nerds will have their own preference and they'll get into fist fights over which one's better, and they all suck still. All of them are rubbish, there is no correct choice. But, you know, you can run your cool programs like, okay, Echo's boring, it just returns whatever you want. You know, you can run your programs like Python, and then, cool, you've got stuff. You're all familiar with this probably. It's not that interesting, but where things do get more interesting is that it can display text. Didn't I talk about this already? Well, yes, but you can display text with a bit of pizzazz. It can get fancy. You can display over existing text, for instance. You might be familiar with the top program, where it just shows you running processes. It's like Task Manager, and it keeps moving the cursor back to the top left, and it draws over the top of what you've already got. And you can display in color as well. So most of you will also be familiar with htop, for instance, which is like top. Oh, I don't have it. Let's install it. Let's see. There we go. There we go, now we've got htop. It's the same thing, but in color, it's fancier. That's very cool. And then we can also do all sorts of really cursed things that different people who made terminal emulators have implemented. For instance, you've got mouse input. Over there, when I've got htop, you can see that I am actually able to use the mouse to navigate because when I click on the terminal emulator, it sends instructions to the program. You've got all sorts of other funky stuff, like dynamic font sizes. This may blow some of your minds, but this presentation is in the terminal. This here is actually just the terminal. I'm running a program that runs this in the terminal. These images are in the terminal as well. It's using all sorts of weird protocols. There's a Kitty protocol, there's a Sixel protocol. And anyways, there's all sorts of other weird, funky stuff. For example, get detect when you resize the window. But what can we actually do with all this? Can we play films? Yes, we can. Most of you may be familiar with this famous animation, which displays Star Wars in the terminal. It's absolutely weird and wonderful. We used to be able to get this on a telnet server. They shut that down, unfortunately. What else can we do in the terminal? Can it run fully functional applications? Yes, again. Many of you may be familiar with the work of Will McGugan, working on Textual, making full terminal applications in the terminal, for instance, posting, which is a replacement for programs like Postman, so you can make HTTP requests. And then you can see right there, it just works. It's amazing stuff. And then what else do we have? Can we run a desktop environment in this? What if you take this to the extreme? Well, okay, let's not push it that. Yes, we can. Yes, we absolutely can. We can do this. So, forgive me for the long URL. I have not pushed this to PyPI. Oh, I need that git prefix. There we go. We've now got an entire desktop environment in the terminal. You know, you can work with this. Let's say I want to edit some code. Let's bring up Notepad here. I feel like writing some Python. Let's just, I don't know.
Is this a terminal in a terminal?
This is pretty much. Well, it's a text editor, but yes. Oh. And then you can change your themes, you know, I don't have much time to show this off now, but you can get different applications to render on top of each other. You can drag them around. And probably the coolest part, there's this browser where I can go end up wikipedia.org, almost terminal. Emulator. Can I get it in time? Yes, there we go. There's a Wikipedia article in a browser in the terminal. Thank you so much. And just before I run off, there are 3 definitions from the Merriam-Webster dictionary. Firstly, one definition is that a terminal is occurring or constituting the end of a period or series. So this is, everything's going to turn into terminal. 3b, it's not intended as preparation for further academic work. Don't do this. Lastly, this leads ultimately to death. Thank you so much.
Thank you very much. That was a lot of fun. Oh, yeah. So just to be clear, all shell sucks, but there is only one true editor, and that is Vim, just to be clear for the record. But thank you, Jeffrey, very much for your talk. Thank you.
Thanks so much.
So I think there is something more to say. One more thing.
I think we just got a notification.
Yeah, right. Sorry. I mean, I need to do this again. So I know you all want to go to the wonderful coffee break, but you have to wait a bit more. We won't be doing this for at least 1 year, unless you attend one of the other conferences we're talking about so far in the past few days. I'm afraid I got another notification. Okay, what's this one?
We're not seeing it.
Is it this one? Lightning Talks wrapping up. Is it this one? It's not working, but I connected it, guys. Oh no, come on, this feels like the first day again. It's coming. Oh. Oh. Thank you, Valeria. I think he must have written this from the train station or something. Hope he gets his luggage back anyway. So, it's been exciting, it's been really great. I need to thank you all, like so many people coming back here every day for the same people doing the same old jokes and still laughing. I don't know what you're on, but please sell it to me as well. Thank you very much. I'll see you next year from Valeria, Les, and Luca. It was a pleasure having you.
Thank you.
So now, coffee break, keynote, then closing ceremony for this conference. Does it include the announcement for the next year, including dates? You're going to have to check and see for yourself. Enjoy your break. Thank you very much.